Well, good morning. This is research vessel Falkor operating in the Gulf of California in the South Pescadero Basin. We are in the early stages of ROV SuBastian dive 466, going down to about a depth of 3,700 meters. We're currently at 1,465 meters. And this is the fourth ROV dive of leg 2 of expedition FK 210922, which is an interdisciplinary investigation of hydrothermal venting in the South Pescadero Basin of the Gulf of California. My name is David Caress. I am the chief scientist here on leg 2 of this expedition. And what we're going to be doing on this ROV dive this morning and through the day is a continuation of what we were working on in yesterday's dive, which was really, from our point of view, very successful. And this is doing heat flow profiles along the seafloor, across and along the hydrothermal vent field that's known as JaichMaa Jaag. And the hydrothermal fluids that come out of the seafloor at this vent field are at about 275 degrees Celsius. What we are doing is using the ROV to locate or to follow profiles and to sit down and insert a heat flow probe into the seafloor and measure the transport of heat out of the seafloor via conduction. And we're doing this along profiles where we have what's called subbottom profiler data, or images of the subsurface, of the upper 50 meters or so of the subsurface. And the point of that endeavor is to try to understand how this hydrothermal vent system works, and how what we see at the surface, and in terms of the morphology, where the vents are, the animals and communities that live on those vents, based on the chemosynthesis, how that relates to the underlying structure. And the broader context is that the South Pescadero is one of the several basins in the southern Gulf of California that are actively opening by rifting the continental crust and initiating seafloor spreading, initiating the creation of new oceanic crust through volcanism. And here in the South Pescadero Basin, we are just at that point where you have the transition from continental rifting to seafloor spreading. And we have these, in this context, we have these vents that exist here. So we're trying to understand how this system works from the very large scale on down to the biology at the microbe level. And the next leg 3, will be focused on the biology and microbiology of this. The reason we've turned on the live stream a little bit earlier than we often do is that we have been seeing some very interesting animals during the descent. And so we wanted to have things going. So as we see these animals, that we can pause in our descent and take a look at them. So for the next little while, I'm going to turn it over to Dr. Robert Zierenberg, or Z, who's a geochemist, but also an enthusiast of jellies and other midwater animals.
All around small guy.
And who doesn't like pretty squishy creatures that we've never seen before? So good morning. What you're seeing right now is water. there's a lot of it. We're going to be diving through about 3,700 meters of it today. And I'm not going to describe water to you over and over because that's kind of boring, but if we see something interesting, I'll try and say what I know about it, like that was a larvacean. But I'm a geochemist. I'm not a biologist. I think some of our biological friends who will be on the next leg are listening, and so I'm hoping they don't take away my bio badge for when I misidentify things. So we'll try and tell you what I know, and we'll tell you what I don't know. Even though I'm a geochemist, I have been out doing marine work off and on. I think my first cruise was 1978, which is well before most of anyone who's listening was alive. We didn't have ROVs like this back then. Now we're going to look at a nice little jellyfish here. It's only been in the last 20 years or so where this kind of technology is readily available. And especially being able to see things in the midwater column just didn't exist when I started. Oh, that's a beauty. I have no idea who that one is. Maybe we've got someone online who could tell us, but that's a jelly that I have never seen. Yeah, that's a beauty. Yeah, I hope we're getting frame grabs of that. Anybody out there recognizes that, we'd love to hear from you because that's a new one on me. So we've got a really nice weather day here today. The seas are calm. I hope the weather's good where you are. I understand the weather's usually pretty good down about the Tropic of Dan, but never been there. So maybe we can get a weather report from Tropic of Dan, see how it is out there. Yeah, somebody thinks that maybe somebody drops a chandelier off of the ship. This is a pretty nice ship, but we don't have anything quite as fancy as that. Oh, that is a beautiful shot. So all I can tell you is that's some kind of jelly, but that's a new one on me. I am not sure how many dives I've done. Let's see, I would say on the order of 20 submersible dives and maybe 30 or 40 ROV dives. I've never seen that critter.
I've seen it before. I just don't know.
Oh, you have?
Yeah,
Okay.
I've seen it before, I just don't know the name.
So we are in the good hands of J-Rod driving the ROV, and he knows that one. Of course, he has seen more seafloor and water in between than almost anybody else on the planet. There's certainly not many other people who have seen that much. He's a great resource when you say, is that new? He usually will have an answer for you. We're glad to hear that it's always sunny in the Tropic of Dan. That's good. And at the home office, they're enjoying good weather. So the home office, this ship is run by the Schmidt Ocean Institute. It's a privately funded research institute. The ship we're on is the RV Falkor. And the Schmidt Ocean Institute makes ship time and ROV time available to scientists. And scientists can write proposals, and if they're accepted, we're allowed to come out and use this wonderful research toys, many of them, to advance the science. And so the ship is outfitted with a lot of great capabilities. It has a great mapping system, which we have been putting to extensive use, especially on the first leg. The ship was essentially just mapping 24 hours a day. You'll see various copies of those maps come up on the screen as we go along. And of course, we have the ROV. The ship can also do CTD, which stands for conductivity, temperature, depth, and it's basically a tool that goes down on a wire with a bunch of bottles, and it measures the temperature, the conductivity, the pressure, which gives us the depth, and a few other parameters, and then we can send a signal at a certain depth to close one of the bottles and get a sample, and that way we can get up to, I think, 20 samples on your rosette CTD.
John, how many
20 on how many?
This is 24.
24. So we can take in one vertical cast, get 24 samples at different depths, and we won't be doing that on this cruise. This cruise has been divided into 3 legs. The first leg was mostly mapping, and the people out here were experts in the tectonics and how the Gulf of California, Sea of Cortez has opened up. So Ronald Speltz was the co-chief scientist on that leg, and had a group of colleagues and students with him doing the mapping this leg. The co-chief scientist with Dave Caress, who's the chief scientist for all 3 legs, is Raquel Negrete, and she's a heat flow expert, so we're going to be doing mostly heat flow today. We'll see that later. Now we're looking at another Larvacean. Larvacean, yeah. That looks like a big animal, but the animal itself, we'll see here as we zoom in. You see the little purplish guy, kind of looks like a tadpole. That is the actual animal. All that stuff around him is a mucus web that he spins, or she. And you can see that there's a bunch of marine particles, marine snow trapped in there. And so this little animal makes these rather large mucus webs as a means to trap particles, and then he finds the ones that are tasty and eats those. And when that mucus web gets too clogged up with stuff to be effective, it'll shed it and it'll make a new one. And J-Rod tells me they can do that and make a whole new house in about an hour or so,
Yeah.
which is pretty amazing. Oh, good. George Matsumoto is on. I think he can give us an ID on the jelly we saw. George is a biologist and one of the public outreach officers at MBARI Marine, the Monterey Bay Aquarium Research Institute, which is the home institute of our chief scientist, Dave Caress. So glad to see George here this morning. And somebody fishy just came onto the chat here, but we haven't seen any fish yet, Noonie, but we'll keep an eye out for them. And it's still a little after breakfast time here, but apparently Alice is having dinner, so I hope you have a nice dinner, Alice, out there. So why do we want to measure the heat flow? Well, we're in an area, as we'll see when we get down to the bottom, hopefully we'll see some of these vents today. One of the reasons we keep coming back to this area is because there are high temperature hydrothermal vents here, and we would like to know more about how they act. It turns out that high temperature and low temperature venting of hydrothermal fluids turns out to be actually a hugely important process in how this planet works. You know that the interior of the Earth is hot and we've got cold seawater above, and the Earth, as it ages, is cooling. It turns out that circulation of cold seawater through the ocean crust, the rocks underlying the ocean, is one of the major ways that the planet cools. And as that seawater reacts with rocks, the rocks become altered, new minerals form, the seawater changes composition, and so there's a huge flux of fluid that goes through the ocean, and that actually changes the chemistry of the rocks, it changes the chemistry of the ocean. And by measuring a lot of hydrothermal fluids, most of these come out where there are volcanically active regions like the mid-ocean ridges. And what we now know is that there's enough fluid flowing through the global mid-ocean ridges, coming out as hot springs near the ridges, that essentially the entire volume of the ocean circulates through the mid-ocean ridges about once every 9 to 11 million years. That's a huge flux, and so chemicals from the ocean water get put into the underlying volcanic rocks, and other chemicals get leached out and put in the oceans. And so why are the oceans salty? Well, in part they're salty because rainfall on the land leaches elements out of rocks and takes to the ocean, and they build up over time. But this hydrothermal circulation turns out to be a piece of that puzzle as to why the oceans have high salinity.
Does the salinity fluctuate?
That's a good question, which as soon as I try and pronounce this jellyfish, I'll get back to that question. Halotraphus. All right, George says that's a halotraphus. I mean, pardon me if I mispronounced that. So George recognized who that was. So since we're talking about ocean chemistry, and there's mostly what we're looking at is water, let's talk about the ocean chemistry. So when water and rain falls on rocks, it leaches out salts, and those get delivered ultimately to the sea.
Sorry, I'm just going to pause that so it's not all the chat stuff right there for you.
And some of you may know about things like saline lakes in the desert areas. I'm from California, so an example would be Mono Lake. Water from the Sierras flows into Mono Lake. Mono Lake doesn't have any outlets, and so water evaporates. Mono Lake gets saltier and saltier over time, and so it gets salty enough to where it builds up and it starts to precipitate minerals. Well, what about the oceans? Are they getting saltier through time? Because there's a fish. And unfortunately, even though geologists are very interested in that question, there are very few samples of old ocean water. How do you sample ocean water millions of years ago? It turns out that, we have to use some clever ways, and people have tried to address this. And what we know is that over the last several hundreds of millions of years, and probably back to about 2 billion years or so, the ocean water chemistry is more or less the same, but we are now getting ways to start to see that change. So if we always have river water bringing in things like sodium and calcium and other, that's a Siphonophore. That's a colonial animal. So how come the salts don't completely build up and get saltier and saltier? And the answer is that if we keep putting things in, we have to take things out. And where do they go? Well, some folks may know about things called evaporites. If you're familiar with the Mediterranean, that looks like a little oh, that's one of his little digestive bodies that have fallen off. Okay, you can see his little stinging tentacles. We'll come back to the seawater story here after we look at this nice Siphonophore. So that was an anglerfish. Thank you, Noonie. Unfortunately, he's gone away, or we've gone away from him. Unfortunately, we didn't get a better zoom on him. Actually, it might be a good thing, Tom, if your digestive bodies fall off. If you're overweight like I am, that might be a good diet trick. I don't know. Okay, so I'll come back and tell you a little more about why we are here at the southern part of the Sea of Cortez. But getting back to the idea of the chemical balance of the oceans. Many folks know that in the previous Earth history, about especially 20 million years ago or so, the Mediterranean, because of changes in the way the plates move, got cut off from the ocean. And the seawater in the Mediterranean Sea and in the Red Sea as well completely evaporated. And when it got evaporated to high enough concentrations, you precipitated out salts like calcium carbonate and calcium sulfate, the mineral anhydrite, and lots of even halite, table salt, sodium chloride. And in fact, there's about 1 to 2 kilometers of thick evaporites of Miocene age underlying the Red Sea and the Mediterranean. And so during times like that, that's where the salts that go into the oceans come out. So the balance of the chemistry of the oceans is always what comes in versus what goes out. And because the oceans are huge, those changes take a long time, and it takes several millions of years to drop out a lot of evaporites. And so the changes in ocean chemistry in terms of the major elements come on very slow timescales. We know that ocean chemistry is very slow over million-year timescales, but can change over tens of million-year timescales. So we're diving down to about 3,700 meters today, and this is an area that was first mapped and explored by Mbari, where our chief scientist Dave Caress is from. And I happened to be fortunate enough to be asked to be a scientist on board the leg when we found these. Dave and his group had come out with small autonomous underwater mapping vehicles, little torpedoes that are instrumented with sonars, and they drive around on a preset course about 50 meters above the bottom, and he had imaged the big hydrothermal mounds that we're about to dive on, or at least the ones to the north, which we found that year. There was also a temperature sensor on the vehicle, so we knew that we had one, big mounds on the seafloor, and two, there was something hot down there. Dave was on the Mbari ship, the Zephyr. I believe he was on the Zephyr. And one of my colleagues from Mbari, Dave Clegg, and I were on the Western Flyer, and we were down on the Alarcon Ridge, which is the northernmost part of the East Pacific Rise, and we were looking at hydrothermal vents on the Alarcon Ridge that are associated with the volcanics that form the East Pacific Rise. Dave Caress let us know that we had some new potential vent targets, and on our last dive, we were able to dive on this site, which is the Pescadero Basin. We'll talk more about what we know about this. And we were able to find on that dive the first known vents in this area and take water samples. Hopefully, we'll see how things go. We hope that we can take water samples tomorrow. That was a Ctenophore from a hydrothermal vent. And, everything is subject to change out here, but the tentative dive plan for tomorrow is we will go back to this other vent field. There's 2 vent fields here that are separated by about 1 kilometer or so. And hopefully we're going to see some really vigorous hydrothermal flow there and try and take some water samples. But that's the story for a little later. So can we look at the chemistry of volcanic rocks on the ocean and the salt level and tell us something about Earth's change over history? That's exactly what geologists try to do. But the geologic record is very spotty. And especially, like I said, we may be able to find oceanic rocks back to a certain age, which are not that common on land because they form in the deep sea. There's a beautiful Ctenophore, and the beautiful colors are a refraction of the lights of the submersible that are flashing off as little ciliates. Yeah, now we're getting a beautiful light through. So, did someone ask what's a Ctenophore? Well, if you ask a biologist what's a Ctenophore, they'll tell you it's a comb jelly. If you ask me what a Ctenophore is, I'd say they're for my amusement and just to remind us of how beautiful the oceans are. So that's the difference between a geochemist's view of a Ctenophore and a biologist's view of a Ctenophore. I think that's pretty gorgeous. And so George tells us this is a Lampoteus Ctenophore, the species Lampoteus. Thank you, George. Also known as a blood belly comb jelly, which is a nice descriptive. And so comb jellies look a lot like jellyfish, but they're actually in a very different family, actually different phylum. They're more closely related to Cnidaria, which I think includes like the corals. Am I right? Thank you, Noonie, for that.
Either or. Oh yeah, they're in that little tubby thing, the pink one and the black one, Sebastian. The bag on it.
So we're at about 2,200 meters depth now. That means we're about a third of the way down. We're going to be going to 3,700, so we still got 1.5 kilometers to go. That's a lot of water.
You
connected through the internet. We always wind up just using flash drives walk across the net.
We don't like anybody being connected to our network on our RV. Bad things can happen.
Bad things happen. That's right.
Well, bad things happen with flash drives too. I didn't say that.
You jinxes.
We at least know where that came from. If we're connected
You know
to our
where
network,
it's
we don't know who's getting into it.
Flash is line and solid.
So George is doing a great job of interacting.
Yeah, that's cool.
Been a couple months since I've done this. I think we're going the right way.
So as you know, we're interested in knowing more about our planet, and we're exploring other planets, but we are right now in one of the least explored parts of the planet. We know less about the deep sea and the water. We know a lot more about the seafloor than we know about the water in between. And it's only been since the advent of submersibles like SuBastian and others that people have started to really be able to understand who and what lives in the deep sea. And one of the pioneering organizations in doing this was Monterey Bay Aquarium Research Institute, MBARI. And they really started putting a lot of submersible time into mapping the animals in the deep sea, collecting them, trying to understand them. And they have put up a nice database where people can and look at the different animals. Maybe if George doesn't mind, he can put up a link to that database where people can go in and look at what's been found in the deep sea and try and identify animals. It's as a non-biologist, it's not a resource I use much, but it's a really nice resource.
Does George know Kakani?
Oh yes. Yeah, they work together. George.
Tell Kakani there is no solstice in the Gulf of California for some reason.
And so J-Rod, George, would you pass this along to Connie? He says there are no solstices. Did I get that right? In the Gulf of California so far that he knows of. And
Everywhere, all the time, every dive.
Yeah.
I haven't noticed one here.
cool. Okay. And Kakani will be coming out to the Gulf of California if things work out. And the MBARI has a series of cruises and dives planned, and Kakani and Dave Caress will be co-chief scientists on one of those legs. And so she'll be out here presumably diving on these same vents that we're going to be diving on. And she does some really amazing stuff using basically geophysical tools to try and understand how animals work, how they move through the oceans, and the biomechanics of things. And if you go back to a previous leg of this Mid-Ocean Institute, Kakani and several other colleagues were out testing new technologies. They were doing some amazing things to try and image animals and really get to understand, not just take cool pictures of them, but understand how they move and how they work in the ocean. So go back to the Schmidt Institute YouTube channel when you get a chance and look at some of those dives and see what they were doing. They've got some amazing toys that are still being developed that are starting to revolutionize how we understand the midwater animals. That's another one of the the comb jellies, Ctenophores.
Jerry, you would be happy if I remove the 464 points? That 464.
You're talking about complete points?
gray lines.
It won't take away the markers.
Yeah. So you've got the blue for you, and then purple for the woody points. But we can change that to another color if that's too fresh.
Those really aren't waypoints, of course. They're just trying to define the line segments. And we want to,
That's what the size of it is.
right. So we want to be able to make sure that we're picking heat flow to the extent possible on places where we have this.
So, J-Rod, turns out that George says they have seen Solomyces here in the Gulf of California. And the deepest sighting was at 2,100 meters. But we haven't seen them yet. Yeah. J-Rod's got an eye out for them.
Okay, thank you.
Awesome. Thanks, Dave.
John? Is this what they're seeing, or is that what they're seeing?
The left one.
It is the left. Okay.
This is the live
It is
view,
that one.
and then all cue shots up there and everything. You might
Okay.
be able to, if you see something coming.
Yeah,
up,
I just wanted to be sure which one. Thanks.
Of course.
Okay, there's a nice polychaete worm. Just kind of hang out. It's a beauty shot. That's beautiful, J-Rod. That's a nice pick.
Try to get the cut. We'll watch it. Swim, buddy, swim.
And is the stomach glowing, Tom asked? I think it's really with the lights on, we can't see bioluminescence. So it's really the stomach is just really white and reflective, I think. So you are seeing some of the innards. You can see its digestive tract there. That's a pretty cool image. And so one of the things that Takani and her group would do would be, you see how this thing is slowly moving its little swimming appendages and ciliates. They would map this in high resolution and in slow motion, be able to really work out the locomotion and how these things are able to move through the water. It's really cool stuff.
Excellent.
Yeah, we got his attention now. Okay, well now we've got a map up that's showing us the view looking north. You see the Sea of Cortez or the Gulf of California. All of the sort of background bluish colors are the seafloor maps that existed before we got here. All of the brighter colors that are highlighted, that's all mapping that was done on this ship. Some of it done back in our cruise in 2018, and some of it filled in now. You see a chain of volcanic craters that are just to the south of where the vehicle is. We won't be diving there. And you see we're heading for a deep hole. You see where the submersible is. That deep hole is what we call a little spreading basin. There's a big transform fault, a fault that moves sideways. So it's that if we look across that fault, the plate on the other side is moving to the right relative to us. And that fault goes all the way up through the Gulf of California and connects to the San Andreas Fault. And that's the boundary between the Pacific Plate and the North American Plate. And right where we're looking in the Pescadero Basin, that fault makes a little bit of a jog by about 4 or 5 kilometers. It jumps over to the west. And because of that, as the plates slide past each other, with the plate furthest away from us going to the right or south, and the plate that on the Pacific side going to the north, because of that little offset in the fault, it pulls apart a basin, leaves a little hole, and that hole sinks down. And that's the Pescadero, South Pescadero Basin. That's where we're moving. Now, if we stretch that crust far enough, it gets thin, and at some point it will start to break and allow melt from deep in the earth, from the top of the part we call the mantle, to come up and form new oceanic crust. And so we know that the Pescadero Basin is just opening to the level that we can start to form new oceanic crust. That's why the crust is hot here. But also because it's a deep hole and we're next to the continental landmass on the Mexican side with rivers coming in, this deep hole gets filled up with sediment. So even though we're forming new basaltic volcanic crust in this spreading center, here it's buried under sediment because the sedimentation rate is so high. So we were talking earlier about the fact that the flow of cold water through hot volcanic rocks at spreading centers is a major part of how the planet cools and affects things like the chemistry of the rocks in the oceans. And this is an important process that we want to understand. That's what is going on here. But as opposed to most places where this happens, like the East Pacific Rise or the Mid-Atlantic Ridge, where you're far from continent and there are no sediments on the new volcanic rocks, when those hot fluids come up, they mix right with seawater and they make what we call black smokers, and they precipitate chimneys that are made of things like iron sulfide and zinc sulfide and copper sulfide. Well, here, those same fluids are being heated by the volcanic rocks to about the same temperatures, but before they get to the seafloor, they have to interact with a bunch of sediments. And as they interact with sediments, that changes their chemistry even more. And what we believe happens is that, in fact, a lot of the metals, like the iron and the copper and zinc that you normally see in black smokers, we don't see at the hydrothermal vents here, because we think they've actually precipitated in the sediments underneath. We'll need to test that by geophysics and drilling eventually. We hope we can do that. But those fluids, when they come out of the oceanic crust, are very acidic. And anyone who's taken a geology class knows that if you put a little acid on calcium carbonate, like seashells are made of, it fizzes and goes into solution. Well, that's exactly what is happening underneath here, is that these fluids are dissolving and picking up a lot more calcium carbonate in dissolved form. And so when those hot fluids come to the seafloor here and suddenly cool, they're precipitating hydrothermal materials, but mostly they're precipitating calcium carbonate. And we'll see the later in the dives, especially in the biology dives, we'll see a lot of these big mounds, and so forming a lot of calcium carbonate, but in this case, very little in the way of metals like copper and zinc. And there is one chimney that we know of right now in the other vent field, which I hope to be sampling tomorrow, that is not made of calcium carbonate, but seems to be made of another mineral, barite. And that chimney, surprisingly, has very highly anomalous levels of gold and silver. And we'll talk more about that tomorrow if we happen to be there.
You say gold?
I did say gold. We have sampled it, and we'll talk a lot more about that tomorrow. The gold runs up to 4 grams per ton, which would be about a little less than 1/10 of an ounce, but that's pretty valuable. The silver, up to about 900 ounces per ton. That's pretty, no, I'm 90 ounces per ton. Sorry, 90 ounces per ton. So I do not understand why that's the case there. I've spent most of my career studying these black smokers, trying to understand how they relate to mineral deposits, especially the kind we call massive sulfides, which are mined on land for copper, lead, and zinc, and other minerals, including gold and silver. And the chemistry of this one site with the high silver and gold is different than any other gold and silver deposits I know about, and that's one of the reasons I'm out here to try and study that. Now, does that mean we're going to see a big mining ship out here mining these chimneys? Yeah, I don't think so. For one case, there's only one little chimney we know of that does this, and it's not very big. And the other is, mining companies mine to produce resources that we need, but they do that so they can make money. Ore is only worth something if you can sell the minerals in it for more than it costs you to get that. The cost that we've put into getting the little samples that we've analyzed for these gold and silver exceeds the value of the minerals in them by a factor of about, 100,000 to 1. So I am not expecting anybody to, there looks like some kind of maybe anglerfish, not sure. Let's see if we can get a little closer to him. So sites like this are very important because they help us understand how gold and silver and other deposits form, and we are still using those resources on land. But the day that we start mining them in the kind of settings we are at 3,700 meters of water, I don't think that that's going to be coming in my lifetime. So maybe a whalefish, Noonie thinks.
How low is it going to remain? Most likely.
Oh, there's a pretty little orange shrimp. Is that a little amphipod that's right in front of him, the white guy? Not so sure. That's not part of him, I don't think.
I don't think so either.
I wonder if he's looking to eat that. He might be looking at that as lunch.
Looks like he's asleep.
Oh! His nap just came to a rude end. So as everyone knows, the world's been a different place for the last few years because of the outbreak of a world pandemic. And a lot of research ships have not been working in this period because in a closed environment like a ship, if there is some kind of outbreak, you can't contain it. It's very serious. Schmidt Ocean Institute has managed to keep this ship working most of the time, and they've done that by putting a real emphasis on crew safety. And so everyone who comes on the ship has to isolate before getting here. They have to be tested before getting on board, and they're tested afterwards. So one of the reasons we're able to be out here is because Schmidt Ocean Institute has tried to keep this working, but safety comes first, and they've done a really great job of being able to keep doing this work and keeping the crew safe. Unfortunately for the people on board, that also means that when they come into port, they're not allowed to go out and enjoy the whatever the local port has to offer. So some of these people, I don't know with the longest running person who's been on board continuously since being on shore, but these folks have been isolated out here a long time. And you would think that people might be getting cranky, but boy, it's just a really good team here. And things are working great.
Okay. There you go. Thanks.
So on the previous leg, when they were doing mapping with the sonar sends sound waves down and bounces off the seafloor. That's how we make the maps. And occasionally in the sonar, we would see reflections up in the water column, which were streams of bubbles. And this has been observed everywhere, elsewhere, sorry. And we know that in places there are vents that vent gases, and the two most common ones are methane and carbon dioxide. And really, to get bubbles at depth, you need a lot of dissolved gas like methane. Because the hydrothermal fluids here are interacting with organic rich seawater, they're breaking down organics to make methane. So one of the things we'll hear a lot about in the biology dives is the fact that there's a lot of methane coming out in some of these seeps, and this is what is fueling some of the biological communities we'll see on the next leg. But on the previous leg, they mapped about 10 places, I think, around this area where there were bubble streams coming out. Hopefully in future dives, when we have these well located, we can dive and confirm what they are. But these are almost certainly gas plumes that are made of methane, because it's about the only gas that can be generated in high enough quantities to make bubble plumes. So will we see methane plumes or gas bubbles here where we're diving? No, we don't think we will, because if we understand, we understand that the solubility of gases like methane, the higher the pressure is, the more gas you could put in solution. Think about your favorite carbonated beverage. When it's sitting in the bottle under pressure, there are no bubbles. Well, when you release the pressure, then the solubility goes down, you form gas bubbles. So the same is true about methane here. So what we think is that at the depth where we're diving, 3,700 meters, the pressure is so high that we will not get sufficient methane to make gas plumes. All right, now on your screen, you're seeing some of the sonar images overlaid on a bathymetric map, and you see these plumes of gas coming up. But what you see is these are all in so much shallower areas than where we're diving. And so we're not expecting plumes here, but these other areas are places where we hope to have dives in the future, and we'd like to investigate this. And so, yeah, now you see the deep hole where the rift is. That's where the ocean floor is pulling apart. So I think the plumes they imaged on the previous dive are almost certainly methane. If they were CO2, the CO2 is so soluble in seawater that even if it made bubbles of the seafloor, it would disappear before it got that high. So these are almost certainly methane plumes. And the question is, why are they located where they are? And we need to look at the maps and decide that, but it seems that some of them are associated with the faults, and that may be providing a pathway to get the methane and the fluids to the surface. Others of them may be located just where there's enough organic matter to make methane. So this is a real question for the future that we hope to answer. Every time we come out, we learn things we don't know before, and that gives us new ideas and new things to test. And so we're in no trouble of running out of things to investigate. Okay, now we're zooming in on our basin. You can see the basin is being pulled out apart in a northwest southeast direction, and overlaying on that is our detailed map. So the background map you see is the scale of mapping done by the ship, the Falkor. Made those maps, sending sonar down from the surface. The colored square is a much more detailed map. So the shipboard mapping is gridded on a grid of 30 to 50 meters per pixel. That's about as high resolution we can get from the ship at these water depths, which is quite deep. The deeper map, the more high resolution map, that shows things down on about a 1 meter scale in terms of the resolution of what we can map on the seafloor, and a vertical resolution of centimeters. Those maps were made with the autonomous vehicle. So Mbari came out with one of their autonomous mappers. These are little battery-powered torpedoes with multi-beam sensors, multi-beam sonars and other sensors on them. You program them to go down to a certain depth. They typically fly from 50 to 75 meters off the bottom. They'll run a grid of lines for 8 to 18 hours, collect that data, come back to the surface. We'll pick them up and download the data, recharge the batteries, and send them back again. So that's how those more detailed maps were made. And only in those more detailed maps can we see the details of the seafloor, like hydrothermal mounds, which are just too small to be seen from normal shipboard mapping. So typically when we study these kind of areas, we do what's called we look at things in increasing detail. So we start with a big picture from a seafloor map, try and get bottom maps at higher resolution, and then go down to the scale where we can do submersible operations. And so it looks like this is another monopsid or a type of amphipod. How long do you think it would take that guy to get to the surface from where are we? We're just about 2,900 meters.
He'd be tired.
He'd be real tired.
It's going up at about 3 meters a minute.
3 meters a minute. He's really cooking.
At 4 meters a minute. That's height.
So he'd get there in 1,000 meters if he could get this up. Or 1,000 minutes, I mean. I don't think Michael Phelps could swim 1,000 meters in that time. So, well, I mean, Ops is doing pretty good. Okay, now we're zooming in on the seafloor in the basin, and you see the little tiny mounds. Those are the hydrothermal mounds. Each of those mounds is about on the order of 50 meters across and 20 to a little more than 25 meters high. They're built up on a muddy bottom of seafloor, but those are all hard rock made of calcium carbonate. So all of that was deposited from the hot fluids that are coming out of them each of those mounds is still venting, each of the big mounds is still venting fluid. The one in the middle, which is the tallest, is the one that has the most active venting. And if you were watching 2 days ago on the dive, that's where we sampled hydrothermal fluids from underneath the flange, and those fluids coming out were 287 degrees centigrade, which turns out to be exactly the same temperature we measured when we discovered those on the Falkor in 2018.
The temperature at which light mounts melt.
I forgot to look at that, yeah. And as J-Rod says, is above the temperature at which lights on the submersible start to melt.
The mounts.
So the mounts that hold the lights. I did not look at them, but apparently when we were sampling, it was a very hard place to sample, and the pilots worked incredibly hard to maneuver in there safely. But we got a little too close on one part of the vehicle, apparently. I'll have to go out and take a look at that tomorrow on deck. I forgot about that. It's a tricky environment working down in the deep sea. Of course, the pressure is high. The pressure where we will be diving today is about 370 times the pressure that we are at in ambient pressure. So that's a lot of PSI. It comes out to something like 50,000. Is that right?
Currently, right now, we are at 4,400 PSI.
4,400 PSI right now at our depth, which is just about 3,000 meters. So,
We got 5,400 PSI.
yeah, so I think in terms of atmospheres, because that's a lot easier. And so at 3,700 meters, you get 1 bar of atmosphere for every 10 meters. So that's 370 times atmospheric pressure. Now we're just seeing a little pan around the vent field. The mound that's over to your left is the biggest and most active one. There's a pair of twin mounds that are covered with tube worms to the north, and you can see the yellow line is a representation of where our tether is on the vehicle. That's where we're diving down to. So we're going to be starting our work right over there. And like I said, the main focus of today's dive, and you'll see and hear a lot more about that later, is to do heat flow. Why do we want to do heat flow? Well, you can see that there's a nice north-south alignment of those hydrothermal mounds. Why is the fluid coming up there and not somewhere else? Well, that's a question that we really want to answer. There may be a fault there. We have some shallow seismic images of the seafloor that show some small faulting, but all we can image is the surface, and what we really want to know is what's going on the subsurface. The heat flow measurements tells us something about how heat is moving through the subsurface. So by mapping the heat flow across this, we hope to find patterns that will give us a better idea of what the subsurface plumbing is, where the water is moving and why it's moving where it is. So that's the real goal of the heat flow mapping. And heat flow mapping is done somewhat routinely on ships, but usually done by dropping a probe from the surface, putting in the sediment, and a high density of heat flow measurements in an area might be 1 for every several tens of square kilometers. We have a small heat flow probe on the submarine, the submersible you see later, and so we're taking much more detailed heat flow measurements around this vent field. When the heat flow experts are coming around here, they're going to be talking about heat flow coming out of the seafloor in the order of a few watts to tens of watts, and occasionally 100 watts or more per square meter. Those numbers are hugely in advance of what above what would be normal in most oceanic crust. It's because we're in this hydrothermal area. So normal heat flow is measured actually in milliwatts per square meter, and we're measuring in watts per square meter. So it's a very high temperature area, but that's why we're here studying it. Oh, I see one of our other pescophiles has joined us. Rayrard and Nooney and I can't even pronounce Yadthraja. Sorry about that. But I occasionally watch Sebastian dives when I'm at home, and I know that this group of fish folks not only love their fish, but they're really good sources of knowledge on who is out and doing what. So it's great to have input from knowledgeable folks who come in and help us out with observations. And we're just going to call, what's his name, Jeff. Hey, Jeff, thank you. Sorry, I'm kind of language impaired.
I think it's Jeff Day backwards. Yeah, fish.
Ah. So that might be Jeff Day backwards, I'm told. Okay, we're about 500 meters away from the bottom now. And the Gulf of California is known as a very productive sea surface area. There's a lot of biological life, and I assume that's why we see so much in the way of marine snow, all the particulate in the water here. Sometimes when you dive, you see much clearer water, but this is kind of typical of what we see in this area, is that a lot of particulate matter in the water, which of course is, to us, what is dust and distractive is the ecosystem and the food source for somebody else. So. We have yet to see an octopus on this cruise, at least when I've been here. Yeah. We haven't seen very many here, but
How far are you away?
about less than 400 meters, so
Minutes? It's
15 minutes away from us.
Oh,
Yeah.
good. Thanks.
So Florence, so the waypoint that they have you drop in on is the last flow measure. And so you should decide how you want them to move.
The last in terms of location, spatially, because the last one we moved back 25 meters.
And that is the point.
Oh no, we should go the other one and then 25 meters.
So you want it 50 meters along the line west of
The
that
last
point.
one, yes, please.
Okay, so we want to let J-Rod know that.
Yeah, what is it now? Sorry.
So the point that we will want to make the first measurement on,
Okay.
the launch point I gave you was the last heat flow measurement yesterday. And what they've decided is the first one they want to do today is 50 meters further down the line to the east
Okay.
than that point. So that's where it
Yeah,
is.
so we're still
Looks like
about a little over 400 meters from the bottom, but we're seeing fish that we can see when we're down at the bottom.
Be on the line about 50 meters to the.
You got it.
Great, thank
So
you.
that's the last point. You measure this. What's the last point?
That was the last point according to the ROV navigation that was in the samples, the sample slots on that side. So,
50 meters.
how much? 50 meters.
Yeah, because
Yeah,
we one measurement, we back up 25 meters, now we went to
yeah.
50 meters.
Okay, thanks. Thank you. What's that? What kind of fish is this?
It's a Cusk eel, and according to our fish folks, these are something we see at the bottom, so you might be up a little higher than usual, not sure. Nice shot of him, though.
Well, okay. Are there gulper eels in the Gulf of California?
Are there
So
gulper
see-
eels in the Gulf of California? Anybody know?
But they did 20. They did that, and they came back. Oh. So that was 19. That one's 20. That's 20. That one's 20. One bottom.
That was just one. That's the one from the last time. That just said they want to more part.
So that should have been one half. I thought we were starting on the bottom right there. I'm confused.
So this will.
Yeah, why would you have more reserves on bottom there?
That was the last.
No, so yeah,
Got it, okay. Are they going to print it out? Well, we didn't let yeah, I'll print it out.
I've got it. You got it up. Open already.
I think they're 8B now.
You got answers to ask.
Yeah, I'll get it. Or you can if you want to. That's the same knife.
Yeah. And these are push it to the same.
Okay.
Yeah, it's kind of cool.
Yeah, they're correct. They went all the way out and then they went back, so they probably went 50 from that. Yeah, but
Let me change this to the one.
Okay.
question. Yesterday's time was kind of like went all the way to the east, did one. Well, I was the mindset with I believe this was like the big sense, right? They want to measure from the anomalies and just
Well, so this is spatially speaking the last one, and you then crack 25 meters, and now we want to do 25 meters.
So here's a different species of Ctenophore than the blood Ctenophores we were seeing, blood red Ctenophores, but same family.
proper.
Getting a little bit of a light show from the ciliates that are flashing.
Let's hope so, right?
Wow, I'm impressed how many beautiful things we saw today on the descent. You know what impressed me the most? The one that had bioluminescence, like a jellyfish.
Yeah, that's not bioluminescence because we
Oh,
can't,
that's
the
effect
light.
of light?
Yeah, but it's and see you're seeing the same thing here. It's refraction of
Oh,
our lights.
oh.
That's why you get the different colors.
Right, but that was beautiful.
Yeah, some of them bioluminescence. You have to have the lights off to see it.
Right.
You want to jump in? You ready, or you want to
No,
wait
no,
till
no,
we get to the
no,
bottom?
no. Yeah,
Okay.
I'll wait until we're ready for the plan.
Well, I wanted to tell you a couple things.
Okay, thank you, George, for saying that's Lyria, near bottom species of comb jelly. So I have a question for the fish folks. What flavor do lollipop cusk eels taste like?
Tartar sauce. Tartar sauce.
Tartar sauce. J-Rod says tartar sauce. That's good. Ammonia, that's probably a good taste. Of course, as everything, it tastes like chicken. Thank you, Ree. So I know they like their fish fries in Michigan. I guess they don't serve that flavor. Is that right, Jason?
So, one thing that's changed, they're showing very lightly on there, but the entire pattern of the subbottom lines is on there now. That's where thinking about operating relative to the whole thing, so that's all in there. Yeah.
Okay. Yeah, I guess.
Yeah, you just barely see it there, but the pilots are supposed to see it.
Okay.
So that's available and I believe in the right place. So no FUSOs is needed. And then the other thing you saw on the Slack channels, that's just to the extent possible, it's trying to engage everybody else.
Sure. So how do we do that? I mean,
We just posted the general rather than, see this down here, this is a private conversation.
Right.
And you can't add anybody to a private conversation. It has to stay private by definition. So you just post in your general Slack channel. And then that's seen by all 30 likes.
I'm going to post that stuff.
we can double kind of
Okay, so now we have a holothurian.
right.
We see a lot of these on the bottom. Occasionally they get up into the water column.
Yeah, and I think that's right. It's just this morning I just kind of realized, Victoria didn't see it, Craig didn't see it, Jenny didn't see it. Discussions about what does it mean
Right.
overall, what it implies. So I tried to cross post stuff, and then let's just try
You're right, but I agree with Victoria, and we just
Yeah,
we
so-
share what's kind of
So we're something like
so far,
150 meters off bottom, give or take a little here. So
so they can catch up with what's going on.
he's in the shape of a question mark, and the question is, what's he doing up here?
just adjusting how we use the slide.
Okay, no problem. Okay, good. ¿Voy por agua a qué se está pasando?
Yeah, I think Rary's right. If we had this isn't the official name of the tool that was on here about 2 legs ago when they're doing it, but if we had the Basomatic on here, then we could probably answer the question of what these things taste like. So, someone wants to know what how J-Rod is flying things, cameras and fiber optics. The ROV is connected to the ship with a cable. The cable has 5 fiber optic.
Six.
Te-
There's 5 single mode, 1 multi-mode.
Okay, so we use 5 cables, and then there are conductor cables that send electricity, and then all that is wrapped in strength steel mesh to, or is it Teflon or steel or both?
Still, 2
Steel.
layers of armor.
2 layers of armor steel mesh, and so we are sending signals down and back over the fiber optic cables to control the submarine and get data back, and then we're sending power down to run the hydraulic pumps and things like that.
4,500 volts.
4,500 volts power. You don't want to be there if you get a short. You'll know when that happens. All the fish will suddenly point north. Okay, we're starting to pick up bottom return from our altimeter. Looks like we're about 50 meters off bottom now, so we're going to slowly make our bottom approach. We should be landing in an area that's pretty flat and muddy bottom. We're about 50 or so meters away from the nearest hydrothermal vent mound. We are landing on the bottom, very near where we made our last heat flow transect on the last dive, or last heat flow measurement on the last dive. And what we want to do is continue that heat flow transect. So we're doing lines of heat flow to try and understand what the thermal structure is, which gives us insight into what's going on in the subsurface, especially where fluids are flowing and what that tells us about the hydrology underneath the vent field. So once we get on the bottom, get oriented, get everything set up, then we will start doing the heat flow, and at that time I will turn this over to our co-chief, Raquel Negrete, and she is running the heat flow team, and she'll talk a lot more about that when she's up here. So rather than me misspeak about what she's doing, I'll let her tell you the truth. And I'd like to thank George for helping us out here on the way down with the species identification. Appreciate having you here. And so I know that we plan on going out to this area with Imbari. George, are you going to be on board with us, I hope? Yeah, we're just picking up the bottom. I can see an anemone down there on the bottom. We're pretty flat and muddy, just like we predicted. Some white holothurians. So we're still about 5 meters up on our altimeter. A lot of sushi in the water today. Visibility is not great, but so mostly seeing a couple of white holothurians down there and a nice flat muddy bottom, which is just the kind of place you want to land the submersible. It's not usually a good idea to land right on top of a hydrothermal vent. That makes the pilots unhappy. It makes the ROV very unhappy. Oh, there's a stalked creature. And it's amazingly few stock creatures here compared to other muddy bottoms where I've worked. We see some, but we don't see a lot of stocked animals like the one out in the background there. We got a fish hanging out in the background. So here we are, 3,673 meters. Nice muddy bottom. Perfect for sticking the heat flow probe into the sediment and getting the conductive heat flow. And now you're seeing a little up close the nice little holothurian. There's an amphipod. I believe that's an amphipod. Someone can correct me. We're doing a white balance on the camera. Some nice little anomalies, the ones that live in the sediment. Real typical of what we see when we're a fair ways away from the hydrothermal mounds. So we move closer to the mounds. What we typically start to see is, it tells us we're getting close. You start to see a few dead clam shells and then tracks from live clams. And when we start seeing high densities of clams in the sediment, or high densities of anemones, if there's rock to colonize, that tells us we're getting closer to the hydrothermal vent field. So we use the animals as a vector to try and lead us in there. So we're getting the heat flow probe set up, letting the instrument take some background measurements. We're getting ready to start our heat flow. Are you ready?
Yes.
All right, I'm going to turn things over to our co-chief scientist. I'm going to let her introduce herself and tell you what she's doing. Raquel?
Good morning, everybody. Welcome to our third day of full heat flow measurements. So as you heard from Z, we're starting our heat flow measurements today, and so we are actually doing the first station already. So pretty much we just left where we left yesterday, and we'll hope to keep up seeing fun stuff like we have, and there are very interesting signals going on so far. So we're looking forward to see what's this Penfield has in store for us, and in terms of heat flow and in terms of anomalies and things that you cannot really predict. So I hope you can stay with us during this intense campaign, and there's will be the occasion to see the animals around here. Our transits are not too far away, but still. And depending on the visibility and if we find any fun stuff to show, I'll do my best to keep you updated. So welcome everybody. Hi guys, hi Ben. Hey, how are you? Hola. Dave, what time we're taking back? Are we at 3 or 3:30? Or you haven't discussed that?
We presume
Well, we're on the
Normal schedule, right?
the normal schedule, so isn't that's on bottom 4, right?
Right.
Yes.
Yes.
So the presumption is 4, and
Yeah.
when J-Rod
Right.
comes in, if he chooses to give you a little extra time, then, but
it's-
basically
it's
we
in
schedule
December.
for 4.
Okay.
Yeah.
Okay. Yeah, I was a little bit messed up with yesterday. Okay.
So we're back on the normal schedule, and yesterday they made it up at just about the right time, so that they gave us another 8 or 9 minutes, worked out. Just, as we get closer in, then we should start thinking about trying to calibrate or speed up if we have to get that extra measurement.
Right. Okay. No worries.
And I have no idea when we're going to want to do this draw on the seafloor for that. But so she'll come back in and indicate when she sees the seafloor she wants.
Right, exactly. And she also pointed out that we might try and do a push core for run at some point. That might be interesting.
Yeah, but it's not the next, the first bit of this. We're heading away.
No.
Yeah.
It will be when we come back and then decided whether or not we're going up north or south.
Mhm.
Okay. Got it. Thank you. Are you happy with the facility last night?
Yeah,
Did you
yeah.
feel the
There
hole?
is no more hole. I'm editing the data right now. but
Okay.
it's, yeah, we did fine. So that's a solved problem.
Okay.
Yeah, and as you probably saw in the main channel, it pinged on Ron. I was kind of hoping that we'd be coming into La Paz by like 2 o'clock or something like that. So see what the captain says. But if we were to go in the water an hour earlier on that last day, 7:30 instead of 8:30, we could still potentially get 2 or 3 hours on bottom if we're only going to 800 or 900 meters. So it's really what we need to find is a spot of interest that's really on the approach and shallow enough that we can hop down and just get on the bottom.
Sure. Makes sense. Yeah, we need to think about it. Really choose our target wisely and try to make as much to get as much of the opportunity to go back for a final dive, even if it's a short one.
Yeah. So hopefully Ron has some notion of what place you want to sample from.
Yeah. I'll plan to call him later. So I'll make sure that he starts thinking about it and see, so we can have a sense of what he wants to do. Sure. All right. Sounds great.
Okay.
Thank you.
You must have lived in the States, okay? Did you
Sorry?
live in the States?
No, I live in Ensenada.
I know, but did you live in the States before?
No.
Yeah.
Oh, thank you.
Never mind Spanish. I was going to practice, ask you, ¿cuánto es distancia para ex objetivo? ¿De hacer?
Sí. ¿Cuál es la distancia para el siguiente objetivo?
Wala?
¿Cuál?
One.
¿Cuál? Which means which.
I know, but I'm asking how much the distance of next objective.
O ya.
¿Cuánto?
O cuánta distancia.
¿Cuántas?
Cuánta distancia. Okay. No, but that's fine.
¿Cuánta distancia para next objective? Next.
Para el siguiente objetivo.
Siguiente.
Please get flow
Siguiente.
out of the seabed.
Well,
So this one, the last one I did yesterday was with the Siphonophore, right? Okay. And the spacing on the previous one was 25 or what?
Right. Clear to move?
Yes, please.
Sí, 25.
25,
Ahorita 50.
50. Hola, hola, buenos días a todos los hispanoparlantes que se unen a al live stream. Aquí seguimos en la cuenca Pescadero. Si tuvieron oportunidad de ver mientras el robot descendía toda la fauna increíble que apareció por ahí, porque ahora sí hubo muchos animales preciosos, de verdad que parece que están como bailando y como que estuvieras en otro mundo. Es que este es otro mundo, de hecho, ¿no? Y desde ahí es como en esta reflexión de pensar que llegamos primero a la luna que al fondo del mar, ¿no? Entonces, bueno, entonces es un privilegio estar aquí y también es un privilegio que estén con nosotros, acompañándonos en esta aventura de entender cómo funcionan estos campos hidrotermales. Entonces, bueno, para todos los que no me conozcan, soy la doctora Raquel Negrete, trabajo para el CICESE, soy catedrático con Ascent y soy el líder del equipo de flujo de calor para esta campaña y co-chief scientist también. Entonces he tenido el placer de trabajar con el doctor C, que ya lo conocen muy bien, nuestro experto en ecología, el doctor Cares, que también ha narrado gran parte de estos live streams, y obviamente mis colaboradores, estudiantes de maestría, Isabela Macías del CICESE, Manet Peña, estudiante de doctorado de la UABC, Karina Fuentes, también estudiante de doctorado del CICESE, y un colega inseparable que hemos trabajado como 10 años juntos, el doctor Florian Neumann, que actualmente está haciendo un postdoc en CICESE con nosotros. Entonces, bueno, esa es la presentación del equipo, que no les había platicado un poquito. Y bueno, pues ya saben, bienvenidas sus preguntas. Y pues vamos a ver cómo nos va en la siguiente estación. Gracias.
Probes on. Okay. Give it a few seconds to clear the dust away. Okay. So we have it clear. Okay, probe.
Inserting the probe, please. As you can see, we're inserting the probe right now after we given time to the thermistors to recalibrate the temperature of the water that's surroundings. And
Thanks, that's good.
what we can see from the graph is that all 10 all the thermistors are registering data. That means it's a good insertion. And so we're now gonna wait for the measurement, which takes approximately 14 to 15 minutes in total. Ok, como acaban de ver, acabamos de insertar la sonda. Es una buena inserción porque, como ven en la gráfica, todos los termistores están registrando datos. Eso quiere decir que todos fueron insertados en el sedimento. La medición dura en total aproximadamente 15 minutos y es una medición completa, si no la mitad. Y lo que están viendo básicamente ahí es la curva, se crea por ese incremento de temperatura que registran los termistores, se debe al calor por fricción que se genera cuando la sonda penetra los sedimentos. Okay, entonces, lo que podemos usar con este calor friccional que decae es determinar el gradiente de temperatura en este punto. Okay, más adelante les explico lo que sigue en la gráfica, y aprovecho para contestarle a Mauricio Cabral, que nos pregunta que cómo poderse integrar un equipo como el de nosotros. Bueno, pues no necesariamente tienes que tener un perfil de biólogo. Nosotros, en realidad, todos los que estamos aquí en esta etapa de la expedición, tenemos formación en ciencias de la tierra, en particular en geofísica marina, y esa es la experiencia que necesitas para entender y formar parte de un equipo que se dedique a esto, ¿no? Pero, como también decía por ahí el SOI en una respuesta similar, pues no solamente puedes unirte al grupo de los científicos, ¿no? Hay todavía toda una gama de gente que está del otro lado, que se dedica a hacer esas expediciones, como los pilotos, los ingenieros, los técnicos de comunicación, en fin, incluso hasta por una carrera marítima podrías llegar a estos lares, depende de tus intereses. ¿Esta es contigua o no?
Más 50 metros.
Estamos decidiendo. We're still thinking about the spacing.
You just can't wait to say it. Okay. Go ahead.
No. Hablas con la que le viste.
100.
Okay. So it's gonna be 100 meters.
Okay.
The next one, but we were gonna do a full measurement, so we'll have to wait the whole 7 minutes after the pulse is there. And then I'm very highly likely that the next one will also be 100 meters. And with that, we will finish this transect.
Yeah, go ahead. No, I'll just get prepared for the next one. It'll probably be 5 minutes or so. Great. Thank you.
If you like that sort of thing. I do like that sort of thing.
Mm.
Meatballs, mac and cheese. Squid. Yellow peppers and onions and mozzarella, which we wanted for. Cheese. Join it, Carl.
Sure, working with you?
Yeah.
Okay.
Buenas noches.
Buenas tardes.
He's going to bed. Everyone works 9 to 5 here. Did you notice the matrix?
I did not notice that for a second. I don't. It wasn't. It's the corruption in the computer.
No. So,
We get
it's the, if you see that thing besides you have all your like hydrothermals, that thing is the viral weapons.
yeah.
J on it.
Yeah.
Recycle powers like that. So we restart the things over the computer. It's like massive computer. All of those show that without anything behind it. And that box there, lines, where the feed is sent to it. That's HDMI feed.
Okay, can you out of the seabed, please?
Okay, so we're done with this full measurement, and now we're gonna move to our next station, which is very close to the end of the transect that we're doing in this particular region of the event field. And maybe afterwards it's gonna get interesting in terms of where we decide to go and in which direction we're gonna do the next transect.
Can I go?
Yeah, where you go? Thank you.
Yeah. 30.
no es la última, ¿verdad? ¿O sí? ¿La insertaremos más rápido? ¿Crees? Por lo que dice, ¿verdad? Casi no insertion speed,
Es que lo
pero...
que no estoy seguro es que siempre lo mismo. Si siempre lo mismo, entonces es algo del wire. Que a diferentes puntos le da diferente. Y si no, pues tiene que ver con, como dice la litología, no es como esto, pero no sé. Tiene que ver. Entonces,
Entonces, ¿esta va a ser la última o la penúltima? Porque dijo, le habías dicho que
no sé.
esta y yo nada más.
Ya estuvo. Y luego aquí, no sé, ¿dónde vamos?
Y en esa última sí vamos a hacer pica.
Sí, para esa punta de cerrado, pues.
Is that the lowest value that we've seen?
1.34. Yeah.
No, 0.74.
Oh, you mean for the conductivity?
Huh?
But I didn't figure the whole question.
Is heat flow of 0.74, is that the lowest that we've seen on this one?
But for this one, it's 1.34. What you're looking at the end is...
Before was supposed to be 0.7. Oh, that's...
No, that's the thermal, that's
Yeah,
the
yeah,
thermal
yeah, got it,
conductivity.
got it.
Yeah,
Sorry.
no, but yeah,
1.3.
yeah.
Probe is on? Probe's on.
Ok, estamos en el sitio de la siguiente estación. Para los que no les comenté en español, terminamos la última. Estamos llegando al final del transecto. Eso quiere decir que esperamos que las temperaturas vayan disminuyendo conforme nos alejamos de las ventilas. Entonces, efectivamente, estamos encontrando valores por debajo del valor de fondo de flujo de calor en esta zona que se calcula que es más o menos de 2 watts por metro cuadrado. Entonces yo creo que en esta sería probablemente nuestra penúltima estación y haríamos una más para terminar el transecto.
Okay, go ahead and insert the probe, please.
Probe in. So you can see, guys, the speed at the probe is inserted is important because you have to be right on the speed where you can produce a decent amount of friction, which is the peak that you are actually looking at in the graph. And if you insert it too slowly, then the friction is not as important and the measurement is not as precise. It doesn't mean it doesn't work, it's just that it's not as precise. And so we'll see what happens with this one. This one is going to be like a shorter measurement. We're just going to take the time for the thermistors to equilibrate after about 7 minutes. And we will just calculate the thermal gradient and infer the thermal conductivity on this one.
Where's your ROV? ROV bridge. We'll have another position for you. Southeast. Updated position. Thanks. Thank you.
Chris, the next station is going to be also 100 meters.
100 meters?
Yes, and it's going to be the last one for this class.
That's the plan.
Well, we plan to go back to the go up to the northern part of the field where the northern edifice is, and then we will take a sample right there to see if it's the temperature is like what we call equal background value, so if it is, then we might decide instead of doing another east-west profile to do north-south profile.
So let's define that point, get the waypoint on there so they know where they're going to move to.
Sure.
So we are not going to, so here's the anomaly from yesterday. So we don't start here and make our way up. We start here and then make our way up.
No, I want you to I'm not telling you what to do.
Okay.
What I'm saying is that
That's what I understood from yesterday.
So we're doing this measurement, and then after this, we're gonna. That's the end of this
No,
job.
we do another one.
Oh, we have
Yeah.
another one. Okay.
Yeah.
So by the time we get to the end of the next measurement, we should have on here the pilots knowing
Okay.
where we're going.
So because I think it's closer going here than going all the way up north.
Yeah, that's what you posted, right?
Yes.
So
I
and
thought
then
that
that's great. We just right now they don't have those points.
they don't have to.
No, because what I did is I put the
Oh,
matrix
okay.
up there, and so
Well, there's two ways to do it, Brian. We can go up north and on our way back, we do these small, you're talking about the small middle transect, right?
Well, I thought we should use
it makes perfect sense to me to make measurements as we're moving up to the north. It's just we didn't know ahead of time where we're going to call the end of this transect. Didn't know, so we need to decide on this map where the points are going to be approximately, and then work with the pilots to get mark points so they know where to go when you say, okay, make that next year.
So, that's what we spot yesterday. Or we can do is, we're finishing here, right? Around here. Okay. So we can move north, to whatever, do these lines and take a measurement. There. Let's say that. Then if it's background, we either decide to go further north, which really doesn't make any sense because we don't know, and then or go south. We try to do this long on the
Yeah, but if it's not background and we have to go, let's say 100 meters northwards, then background and we have to go all the way back south, so we lose a lot of time.
but
I
why
think-
we have to go back all the way back south? We can do the measurements a long way south.
Yeah, but if you start to measure everything, you take one here, then you take one here, then you have to fly here. So it takes more time. So I think it's better to go here and start to make all the way up there to that.
Well,
That's, I mean, it's, in terms of time, it's not really more efficient to go here, start here, then you can then always come back and then do it.
yeah, but if you want to do the whole transit, you will also want to go back here. So if you start in the middle, then you don't save that time. I mean, it's that constant time. You will still have to do.
Yeah, but I don't think we should do one here, then go back. We should start something and then go all the way around.
Yeah, that's what I was saying. Yeah, the only thing that we can decide on the flight is if this value is not background, then
Yeah, then we use the time to go first up and then go on.
Yeah.
That's the time.
but not as much as going all the way up, and then come all the way here and then all the way back. We still have, a pretty good chance that it's going to be back. But we just have to.
Please get the pro out. Es como un podcast.
Perfect. Yeah, we can move now. Thank you.
Okay. So while they're making that move,
Yep.
by
So Carl wants to go up here.
so you want to go to the intersection of these two lines right there, and pick our guess there. So that I think is a point we can identify over here pretty well. So we'll do that after once they sit down and they can touch on that. Okay.
The lateral, do whatever you want, buddy. As long as you end up on E4 24, or reach the time frame, however you get there.
Ayer estaban irreconocibles.
So after we get settled in on that, we're going to the next place we're going to go to is going to be the Sediment.
Do you need some?
be to the northwest. What's that?
You need a land longitude.
No, because we have the grid of lines. So that's where
The grids are
so
in.
it's going to be up to the north of there. I don't know if you want to try and find it right now, but can we see that background with the lines of the door on the thing? Meaning the subbottom lines. Oh, that's good. So those the white lines here. Yeah. There's an intersection. Yes.
Right there. The intersection.
To the left, okay, go to the right, on the right side.
Yeah, that right there. We agree, Florian. That's what
A
we were
little
talking
bit on
about.
the right, I think in the middle between the two. Yes.
Okay.
Yeah.
Okay.
You want it right on
The line.
Okay, so yeah,
So
right on that
there.
blue line. Yes.
Okay.
That's good.
So let's make that the next waypoint.
That'd be 25. Our plan would be at 25.
Sounds good to me.
And I'll adjust it as we position on this one. So we can
Yeah, I just figured you're gonna wind up moving the ship on this one. Thank you.
Green cake. Green cake. A little bit. How far are you? I'm gonna come down with the coach a little bit. Okay. Because I helped you a little bit yesterday. Yeah. Good. Yeah, it's knocked off. A little bit. Yeah, it's interesting.
Will give you my feeling. My feeling is that you know where it is, and you know where it is on the map. Might be a little better than that, but I think a 2 standard deviation. Real certainty is 5%. Also, just to comment on that, this is really, really good.
But
So you should get used to that as being what you normally get with the ROV ROVs. This is just really solid.
But is it like the error between the ship's position and the position?
So what's happening, what is happening is that the raw USBL hits have kind of a standard deviation of 10 meters, maybe even a little more. But they're not getting excursions, and or at least those are pretty rare. And so that going into the Kalman filter that's running in the INS is giving us a very stable navigation. And the kind of moves that we're making, where periodically we get off bottom, every time we're moving, we're getting good DVL. We've got good weather, everything is cooperating. So this is about as good as it possibly can be. Okay. So 5 years. Yeah, good.
No entiende el rock. No entiende el rock. Porque dice, entonces no sé si podemos tomar un print screen con el mapa o...
No, el mapa está ahí en el chat. En el grande, creo, en el de todos, aquí en este. Pues, sí, eso, yo pensé voy a empezar aquí y luego irnos así, porque es mucho más cuestiones de tiempo y eficiencia desde aquí por cuestión a veces, pero bueno, pues ya se decidió ahí en ese momento. Probes on?
Not yet, stand by. Left.
Yeah, fly another
Sure.
3 meters forward. Then even the landed on red body. You seen that?
Punto 82. No, pues el otro va a estar.
Yeah, so like road tree path.
So, point. Sorry. Looking at the map, and just so you understand, the lines that are on the map are where the subbottom lines are really going. So the offsets have all been taken care of up there. So if you want to be between the lines, then that's fine. We were trying to hit the lines offset's not there on this. So
That would be that's inaccurate.
okay, so that's what you're showing is the lines are offset, but they're the opposite way.
Yes.
Okay, so you're trying to be on a second.
No, I'm trying to be between these. I think,
You want to be between those
Yes.
lines, and you want to run down
yeah,
the east
because the
side of the hill.
anomalies
Okay.
Yeah, let's
Okay,
that's
all
a
right.
straight line, and I think.
Okay,
it
so
will
it's all
actually
good.
be-
Then
Yeah,
yeah,
right.
this is good. Okay, all right. Thank you.
Thank you.
Yeah, here's CCI. Here's so I'll turn north. Turn north.
Are you good?
No. This spot is on a pretty decent gradient of a hill, so he's just gonna try to turn into it. So this is one of those. Yeah. So that if not, then we'll be rocking.
Yeah, I saw it on the measurement, so we got a lot of wiggling here. So I don't know
Yeah.
if everyone got-
Thank you.
We'll get off the mark.
I mean, if it's not possible, it's just.
He's gonna try to turn a little bit, sit like on the hill instead of sitting sideways on it, sit like that on it, and it should stabilize it some more hopefully. Yes. The trash. I saw those lists. Everybody put J-Rocks. I think I can say there now. Okay. Yeah. Directly through you should. Slag it like that. There you go. There you go. Start it up. Increase it.
Jason, we're still here. It's just like the pilots are positioning the robot so we can start the next measurement. And not too much action and a sandstorm coming up, but yes, we're still here.
We're still pitching just a slight bit, but our roll has been solid 2.5, so that's good to do with this spot right now.
So we're good?
Yeah.
Okay.
So we are starting the next measurement, and as you can see on the graph, we're giving the thermistors time to stabilize, and also for the pilots to have the camera that's pointing towards the probe to clear off. It's a lot of dust, a lot of mud, sorry. Sediment will be the right word. So we need to have a clear image of the skid cam. And in a few more seconds, we will be ready to insert.
Okay, go ahead and insert the probe, please.
So I hope it's clear enough for you guys at YouTube, but you can see the probe is inserted slowly, but we have to be careful and not to hit any hard object or surface and bend the probe, because it will destroy it pretty much. But it also has to be fast enough to produce a good friction pulse. So that's what's happening right now as we see the spike forming. Creo que el amarillo nitro. Es que es el mismo tipo de sedimento que es como súper aguado y es cuando...
No, es que estamos así. Ok, entonces vamos a hacer así. Después, es que pasó la rechazada también.
It's focused. It's stuff right in front of you. So,
Sí, no está.
I think they switched that. I think that shape fixed that. I think.
Yeah.
On the next move, you must get that fast.
No, go there as fast as you can, please. Okay, so just for clarification and further knowledge for our audience, so the yellow thermistor is actually the top master mister, and the black is it's on the lower end of the probe, so it's the one that goes deeper into the sediment. So this is one of those measurements where, since we are located on a slope and the sediment is very, very soft, so we had like a partial insertion, and you can see the yellow one, that being again the most top thermistor, is not really into the sediment, so it's a partial insertion, unfortunately, but it's okay, we can still manage.
I'm gonna run and get some lunch.
Okay, perfect. Enjoy.
Figuring you guys are gonna
No,
stick it out here,
yeah,
but
yeah.
think
things are pretty well defined. Or
Yeah,
comfortable
yeah, yeah.
with that next
Yeah,
move?
we're
Okay.
just gonna jump to the next point. You'll
Yeah.
probably be back before we are there.
Yeah,
So
probably.
but yeah, take your time. Enjoy your lunch.
I'm gonna run the lunch. You guys are comfortable with that next move?
I recommend the macaroni and cheese.
Okay, I'll keep that in mind.
Aunque sea de chiquita.
Está adentro. Está adentro, no más en el todo. Sí. Bien, aquí se ve.
I have a question for Jason in Michigan. I was reading about some big lights in the sky the other day in Michigan. Was it from the satellite then that everybody was commenting on online the other day?
Russian satellite.
Yeah, much people in Michigan were saying that. So lights. Alright, I'll look it up. Get really hot.
Yeah.
Come down out here.
Yeah. This fueling should be finished in a few minutes.
Suggest turning off your
What that's a question for me then?
No, if you're, I'm just saying that Orion should be finished in another minute, so I'm just getting on this position.
Oh, well, yeah, we're actually gonna be doing a complete measurement, so it's gonna take longer for this one. Another 10 minutes?
10 minutes?
Yeah.
Alright. We'll go over this one again. You bring in presents.
Ok, ahora el turno para los hispanoparlantes que nos acompañan en esta transmisión. Lo que están viendo en la gráfica es que se ha disparado el pulso de calor de la sonda y vamos a ver la señal de cada termistor cómo decae. A partir de esa información vamos a poder determinar las propiedades térmicas del sedimento, en particular la conductividad térmica, junto con el gradiente de temperatura que tenemos, vamos a poder calcular el valor de flujo de calor, que por cierto ya en estas regiones del campo debe de ser muy, muy, muy bajito, por debajo del lo que llamamos el valor de fondo, que sigue siendo, por cierto, mucho más alto que en el promedio del fondo del océano, que es de 0.06 watts por metro cuadrado. Y en unos 7 minutos más estaríamos terminando la medición. Aprovecho porque sé que Elian, ¿estás ahí? Ça va, mon amour? Te mando muchos saludos, Elian, ¿eh? Aquí tu tía desde el barco, viendo el fondo del mar. ¿Qué tal, eh? ¿Quieres que mueva la cámara? Para que tu mamá me diga. Pero por lo pronto te mando muchos saludos a ti, a tu mamá Carla y a los Sabos. ¿Ok? Saludos, familia. Ups. No. No, ya. ¿Este es el final? Sí. ¿Qué? Nos trajeron a chicles. Thank you. ¿Qué? No. I know, but no.
¿Cómo ves, Raquel? Raquel, 50 metros para evitar que estemos así. Y ya vamos a hacer una rápida y nos regresamos. Es que yo creo que es una falla. Si vamos a hacer una más, regresamos así. Estamos justo acá en esta falla, ¿no? Si vamos 50 metros más, hacemos una rápida y ya nos regresamos. Para evitarnos que esta no esté tan buena.
Okay.
¿Cómo ves?
Está bien.
How much longer do they have, Florian?
Wait, we were just discussing. This was supposed to be the end of the transect, but we had one of the trimesters that was partially inserted, and we are kind of on a tilted surface. So we're gonna do one more.
Can we stop this one? Because we're in a bad position.
No, just finish it.
Just
5 and 12 falls.
Yeah, it wasn't bleachers.
This is a 40s actually.
We landed, and we would see what if it was more than that, we'd see it over here. So, we got
Clear it out.
100.
Yeah, like even coming down to it, they were like 60. Go much before you miss it. All right, so sorry, which way are you leaving this?
To the east along the line. Okay. The check marker.
Let's just find a flat spot.
Yeah.
So to the next marker,
Yeah.
50 meters.
Yeah.
But if in transit you find a flat surface, it doesn't. You don't have to go all the way there.
Okay, I'll come down
Yeah,
here.
once we get up this little transitional bridge right here,
Yeah,
it should flatten out.
yeah. It's a good spot.
So yeah, we've dropped
10 degrees.
2 degrees in like a minute.
Okay, you guys are cooling up.
Yeah,
So we're still high. We're not.
Yeah, so our motor, which is like we pump voltage down and it turns data.
Right.
It's heating up more than usual,
Right.
and we got to be very mindful of
Sure.
that.
No, but it's okay.
We're cool now, so we'll just manage it. But yeah, we went through. We have 3 alarms. We have 2 alarms. We have a warning which comes off at 55 degrees Celsius, and we've got like a critical which is like 60, and then we were at like 66 degrees. So we wanted to cool off really
Really
quick.
fast. Sure.
Let's go down now.
So that's because you're trying to get the RV position. Well, it's at the motor.
Yeah, so when we use a lot of like thrusters, the motor requires more amperage, and amperage heats up the winding in the motor itself.
Okay.
And then we get a temperature.
Okay. So it's a motor temperature.
So normal temperature is like 50 degrees. So if you look up here on the right, it's the motor temperature, MTR temp.
Okay.
So like the standard, like the good temperature is like 45. 50 when you're like running a little bit hot. We get low warning at 55, which means okay, you're starting to get warm. You get like a real warning, like 60 degrees, that's you're too warm. And then we were 70% degrees over that.
When you run it, 70?
Yeah,
7.
we were at 66.
66.
We're at 67 the highest.
Yeah.
Okay.
So yeah, in the future, if we can
Then
avoid
before you
any uneven surfaces, because it also messes with our Seafloor water.
Sure. Yeah.
So for you guys,
I
it's
never thought
also
about that, that's right.
right. So yeah, we just avoid it, and even if it's at the marker point, then we just move until we find a reasonable surface for.
So I'm gonna change this next marker to equal 24. I'm just abandon the last one, or we can keep that.
No, it was a bad measurement anyway.
So just abandon that last one and make this one equal.
Yes.
You can't tell if this is flat or if it's sloping down.
That's how good.
This one, the very first one, which is
This is the base of
yeah, you can pick one.
It started to become cave in.
Yeah, maybe water.
Oh, okay.
So maybe the water flow something and it's
Gotcha.
true. It looks nice. So it was a bad measurement somewhere. True.
Because I have slightly different
Yeah, and
signature on the others.
sort of after a list of days, maybe you have some.
Oh yeah.
It's going down. It's hard to say. It was a very bad decision.
Okay. Thanks.
Thanks.
Ah, sí.
I'm almost at the marker here, but this is quite flat. You want to try here?
Yeah, that's perfect. Thank you.
Let's move the ship closer.
Where's your RV? I'm looking for the southeast.
Bless you. Sorry for the sandstorms, guys, but it will clear in a minute. And you will still have the chance to look at the what is the holothurian? Oh, Rachel says sneasels. Oh, I mean, I got your point, Rachel. Thank you. Ah, mira, que sí pudo converger la última medición. El ROV. Que pudo hacer que convergiera la última medición.
Let's just jump onto the sandstorm here so we can improve it. Actually, start to clear it out.
What was on?
It's on, yeah. Do you want me to probe?
No.
No, just give it a minute, please. También para que se aclare la imagen. Me dijeron que fue muy rápido. How much do you think it will take us to go from here to the
45 minutes.
4 or 5 minutes?
25 minutes. Sorry.
25 minutes? Nah.
Where do you want to go?
It's 450 meters at 0.3 meters a second. So 20 meters a minute.
Up to here.
So 25 minutes. 20, 25.
That's, where is it? No,
And so,
it's the,
that's the point.
yeah.
How long would it take to let's say here?
This marker here on these beds here.
Let's say here.
There.
A little bit. Yeah, let's say here. That's this green one.
Yeah, 300 meters. Yeah.
Just at 400, so it's like 20 minutes.
Okay, it's the same. Almost 25 minutes.
It's the same. No, let's go to the north.
Okay, please insert the probe.
That's at
Okay, probe coming down.
0.3 meters a second, which is that's a little bit.
Right.
Okay, that's in.
Yeah, sweet. Esto nada más se mira bien que flore, ¿no?
spy shots of the Bronco.
That dude, but no Bronco.
I got a email from the very beginning saying oil free whatever. You would get higher rate of return or a lower rate of trade than these housing coverages. And the vehicle that they use to advertise their tech coverages was a Bronco.
No way.
I was like, I think this.
So, are you gonna act that?
I'll have to talk to the dealership to try it at the 11th time.
I definitely see it. So that yellow didn't curve off as nicely as the other days, eh?
Yeah, it's the uppermost, but Mr.
So you're still happy if it moves a little bit? Because I noticed yesterday it was quite a bit higher.
It's fine. Cool. And if it's not in, we can only use the 4. So. And it's also not that hot, right? If you see it, we have about 2 degrees, and the deepest thermistor shows about 2.5
So
degrees.
oh,
0.5 degrees between the seafloor and 60 centimeters.
What was it yesterday? What was the best results you saw? Got higher, wasn't it?
2 degrees,
That's
almost
quite
2
a lot.
degrees, yeah, it's a lot.
And those were closer to the vents, though.
Maybe we see them too today too.
This far
Once we come further south to the vents, we should expect higher inflow. Let's see.
I like this camera. That's really good.
Yeah, this one, I think this one down, so you can see the porch, but
I was missing it. That's all right. Yeah, that'll turn it down.
yeah. I don't think it's much help for it.
Oh, right. Yeah, I can see that. Flat there. Oh, yeah, thrusters came down. So, yeah, you guys must have missed it.
We were just saying tired.
Little hill, little bit.
There.
A little bit far.
That's probably not. This is following down the center of the relation semester. No. I just had to yeah, it's not like it's just like a little top graph from the back. Yeah. Check it out. Let's get this one.
Are you gonna? This one. What do you call that?
And the heat pulse? No, it's gonna be a short one. So we should be done in a minute or so. And then we just take off.
To the marker there?
Yeah, to the
This-
marker.
This one here, right?
No, to the one in the north side. Which is it's right here where the waypoint is.
Waypoint 10?
Waypoint
It's
10.
right here's our next spot.
Yes. It was already defined by the. Oh, yeah.
Okay.
Right there. So it's a little bit further.
Here,
there.
look, it's a
You missed the emergency.
Oh, sorry.
So we were on an even slope, and we were doing a full measurement. And yeah. And yeah,
All right, now we're gonna go to the one to the northwest.
yes, please.
Bridge RV.
Full throttle.
So you had to redo a measurement.
No. The problem is that their model got really hot, really
Yes,
fast.
we're gonna make a
So,
fairly large move to the
we were
northwest.
2 minutes
We're
away
gonna
from
try to get there in a
finishing,
hurry, so
which was already a
I'll move
sketchy
you that
measurement,
direction.
Okay.
because one of the
Wanna go
thermistors
0.5 if you could.
was kind of shallow.
That's what I thought I saw in the
Right,
slide.
yeah, and then
What's that?
and then they said you have to go up because it's just getting over.
Thank you very much.
Like they used to explain it, they have this first it's a warning, and then the second alarm should be at 60 degrees, and they were already at 67 degrees.
Okay. Is that actually the HPU or is that something else? You might remember, but it's still named.
Okay, guys, so we finished that last transect, and then we are moving on to a different part of the field, actually the northern part. So it will be a while transiting all the way up to the north, but then you see the fun 3D bathymetry images and the ROV moving towards this point where we will start our next transect. So we're just hanging there. It will be approximately 15 minutes or so.
It was originally built by ISC, but it's you know, there's nothing left of the original anymore. It's still just, it's 1850 meter rated and it's roughly the same size. And I believe that there's screwed onto it some piece of the original frames. That would be it. So, did you capture in your notes or in the Slack channel that event? What went wrong at that time? So we should be sure that I'm kind of using the Slack channel as my history.
Okay. That's your logger? No, we didn't
Yeah,
do anything.
I haven't been taking a separate log, but we should make sure we remember that happened. It's not something. Actually, will that event show up transparently in the SuBastian logs?
I don't think he heard you.
We're heading. We're heading up north of. Yeah. So. No, Orient.
Yeah, we haven't seen any of the Seafloor, so I can see what's out here.
So once we get to this next point, we're gonna transit southeast then. Once we get to the next big point, we're gonna
Oh, yeah,
go down
we
this
were
way.
gonna transit southeast.
I don't know what I found out about is the overheating event, capturing notes somewhere. So this is what we've come out here as far as we did, which was actually not there. And they're moving up to there. That way, transiting over to there, and then flooring wants to come down this corridor. Okay. In between those two things. So it looks like we didn't. No, we did not go that far. We only went about this far.
177.98.
No, the map there is correct. There's an offset on this map relative to these lines. No, I believe that's correct. But
So did we make a connection
no,
right there?
no, we did not. Oh, you're looking. Yeah, okay. You're correct. I'm sorry. Yes, obviously we did.
Okay, so that is right.
That is right.
And what were the last two?
Point, well, we have a like a sketchy measurement of the previous one before we went down, and that was because the slope, we're kind of slope, and so we have like a partial insertion. But the world had the data to converge anyway, so we had a value. We have a point.
So
The point 0.98 is what just got posted.
No, yeah, but the previous one was.
The 0.69 is what I see.
0.69, exactly.
that's really low.
Yeah.
Of course, that's certainly hunting.
Yeah,
But
right.
no, the scarp.
Right, right.
Okay, cool.
transfer.
Yeah, but you see we're up in that little Falkor waypoint marker? You see that far away?
Yeah, we haven't had any diagram here.
You see that far away?
What we see anyway.
Okay.
Sure. All yours.
No, I can see that. I'm fine. I'm fine.
Well, if we want to narrate anything onto the audience, no?
If I see something, I'll jump in. So now that looks on the third. So as far as looking at the side, we're doing something interesting. It's got like the background.
Okay.
So I'm still impressed with this. Very different.
So you're seeing at the mineral grain level evidence of, of average.
No, not tectonic figures. It's like there are ultimatum levels.
So, you gotta get up 10
So
minutes
when
break
you say
before
models,
back.
you like seasonless or yes. So it's an intact piece rock that has and when you say
Right. Okay, okay, I'll be back.
okay.
So far, I'm not third right now. Don't really need the probe to answer that. Still, those are very rare.
Yeah. Okay.
And if we take it.
Okay. So
We'll flip over.
Check the arrows CTD and see what the depth is on those guys. Because it's possible that I think yesterday
Arrow.
well, you're on arrow.
Yeah, we should be on your own.
What sign S? Yesterday we found my S was like 10 or 12.
It's 36 to 80, so. Yeah. Well, is Barrow worth it? Sorry? Is Barrow worth it? John mentioned it. What's that? Alright, so now Barrow is up.
Guy converts off your skill. Just going full ahead. Yeah. Yeah, sure.
Tell me what you got. Archer, we are moving at 0.5 meters per second right now for the water column. Ship's going a little bit slower or faster depending on surface currents. Yeah.
So, based on that, so that's the second round,
It's in between. It's on the far horizon. So here's the question. When we go off the square, I would say we're sort of going in this direction. Here, it's not clear where it's going to be. Is the background doubled out there because we're on ocean across our things that we're in? There's a background out there, it's 2.3, and now it's not. We do see the difference because of the underlying rocks.
That's a good question.
What do you want to do? I want that to be the case. You want to throw that out there to the
C is thinking.
usually Heathrow, so it would be long profiles, drilling.
Because, you know, I got an email from Dave. It's like, I thought the background was about $2.
Yeah.
I think maybe this is why. You want me to run that up and say? Busy.
Well, I was just adding something here. One thing I do want to do with Florian here is validate what I just posted about the overheating event. So, because I can add it to this one every time this one goes, right? Ultimately, our cut is this next set of notes that this picture does. For me, this is one.
Sure.
I don't know about the overheating.
Okay, so I think it was
Yeah,
during
correct. 0.5 meters per second.
measurement 3. Is that accurate? That's what it happened?
4.
It was during measurement 4. Okay, so let me edit this. Okay. And so the electric motor drive of the engine overheated and the measurement was interrupted by coming off bottom. The ROV reset and the measurement was redone. Is that accurate? So
Just stop the measurement. It's also already so far.
So
Noisy data, that's fine.
okay, so the comment should be
Bridge RV, come on, a
however,
little bit slower.
the measurement was generally still be confused.
Noisy,
Echo.
better.
Yes, you do. However, measurement was judged to be noisy, but still usable. That's accurate. Okay. The problem was that there was enough slope that high force was required to keep the ROV stuck at the bottom. So instead of this, they needed to move it down. And this is because the reason for doing that is it's necessary to get all the thermistors in the equipment. That's why we wanted to rotate it down. Okay. All right. So just wanted to get that.
Yeah, we should have like 2 or 3 installs and stuff in our show.
Yeah, well, that was they've been doing that rotating around.
I was ready for I should have told them they should they further so we don't.
Yeah.
So this was an eco subchat, right?
No, this is the primary.
Okay. I'll go, since I can't see the Seafloor, I'll go right up to my hypothesis, get you to think about that.
Yeah, that'd be great. Thank you.
So the target is where your hand is.
Yeah, on his screen it's the
Oh,
inflow
okay.
25.
Oh, okay.
100 meters.
Can you manipulate both arms at the same time?
Yeah.
Okay.
Can, but the person that's doing it, they have to do it with 2 hands.
Okay.
It's usually easier if you have one and one.
Maybe easier or harder to take the master of the indoor and it's the way to do it towards the
And is one arm stronger than the other one? You get more.
Sure. No, they're both the same.
Both the same?
Yeah.
Okay.
Yeah.
nuts.
Like to the right.
Yeah, if you're gonna have that orient in one direction so that instead of
Now, maybe
this,
maybe
There's people.
No, they swapped the cars out in this second. It was just we're
The lighting looks alright. It's still bright. It's great. Why don't we just take that whole frame right off?
more on the seabed. It's not that bad.
It just stays in straight up.
It makes a difference. It's a little bit more down there. It's not very. Tape on?
I think we can see a piece. I can tape on the rope.
No, they taped it up with a frame.
Yeah, I saw that. I think that's a little piece right there.
Yeah, no, there. Yeah.
We're able to start thinking around there, start covering it. Think it's that one. Easy. Give me that HD too. What am I looking at?
Yeah, I saw that yesterday.
Oh, it's because we never see it.
Right. Yeah. Yeah. Because we're sitting too far up.
Yeah.
Well, not sitting too far up. Sitting higher up. HG2. So. Alright, so
Almost there.
Almost, yeah, we're 10 meters away, we have to come back down. We're following this blue line, correct?
What's that?
Once we set up on the first marker, then we're going to follow southeast on this blue line.
No, we are not. What Maureen and Raquel want to do is run more south, but let me show you the map that Maureen did here. So, here's, let's see, do we both want to look at this? Chance? So, you just come up to that point, and so we're going to want to go kind of right down between these two lines that are on there. Okay. So we're skirting the reason is that the leak flow is higher over here and down that transect. So now we're going to do a semi-orthogonal. Okay, got you. Thank you.
So Ron is very excited about that top thing. And he's
Yeah, well,
he's
that's why I
starting-
didn't want to tell him prematurely, because
Right.
it'll be very cruel if it doesn't get out.
So he's just gonna start thinking and look at the bathymetry and all of that. So he's gonna have a couple of places.
Hey, Thiago, yeah, if you could stop there, that'd be great. Thank you. Very few that you went down.
Oh, definitely, that's, I have one car that for us.
We were doing 15, 12. It will run, it's just like this way. I think it's a water around the Larvacean. fish is literally on the spot where you want to send.
Oh my gosh, that's fantastic. Okay, he's gone.
Alright.
Are we looking
Sure,
towards the wet field, or are we looking north?
We're looking north right now. You want to suspend or you want to stay north? Take purpose.
So I think the preference is for you to be able to sit down properly to get the heat flow in, whatever that is.
Okay. It was pretty flat here, so it shouldn't be much.
Okay, people, thank you for your patience. We're finally here. After a few minutes of transit, we are actually at the bent field, at the northern edge of the bent field. And so we will start going north-south this time. And so we're gonna get to see the chimneys in a little while. But this is a spot we're gonna take our first measurement of our third transect.
What is on?
And well, just for those who are new to this stream, this live stream, we are at 3,700 meters depth here in the Pescadero Basin in the Gulf of California, in the JaichMaa bent field, where we are performing a heat flow survey. So let's literally wait until the dust settled to initiate with our first measurement of this last transect. Bueno, estamos de regreso. Gracias por la paciencia. Después de un tránsito de unos 500 metros de donde el punto anterior donde estábamos, que le toma al ROV unos 20 minutos más o menos. Llegamos al nuevo punto de inserción que va a marcar, esperemos, a lo mejor el primer punto del transecto norte-sur que vamos a estar haciendo en el campo de ventilas hidrotermales, JaichMaa.
Okay, coming down. Did you want to probe it first?
No, I think it's fine.
No, I think it's fine.
Okay, coming down.
Thank you. Y nada más recordándoles a nuestra audiencia hispanoparlante que estamos a 3,700 metros de distancia. Sweet. It's gonna be hot. No near background value here.
Well, that changes things.
Yeah. But that's what Florian had considered. Like, if it was high, then we
So
should
now,
go
now
more.
you've got the thing
Look
that's,
at the seafloor life again. So it's just
yeah, here we are. It's warm,
And it's
there's
very
a lot
hot.
of light.
and it's hot.
And it's hot.
Yeah, and
Oh yeah, it's 4 degrees down there. What was the other one, 2?
No,
Yes.
the last one we did was point
0.5 difference.
0.35 or something like that. The
Yeah, so
background heat
What
flow
do
is
you-
always 2.
we go north until it decays.
Yes.
Okay.
Yes.
yeah,
Yeah.
that would be my thinking.
Okay.
Yeah.
25 meters.
25
Yes.
meters north?
Yes. Yes.
Since we know we're going to have to come back south, I suggest make a large move
Oh,
or a
that's
large-ish
true.
move because we're going to come back
Yeah,
this
that's
way.
true. That's true.
So let's take a shot at finding out where, at least 50.
Okay, and then if you want to get in a smaller space, and you can do one in between.
Yeah.
See, but it's good strategy because if we feel like we need to fill the gaps, we can do it on our way back.
Sure. Okay.
So we got really
So it could be like, well, as rough if you
Oh, let's go 100.
100,
Let's go 100.
we could go 100 then.
Yeah. Okay.
Okay, so the next move will be northish,
Straight
100
north?
meters.
Yeah.
25 meters?
No, 100 meters.
100 meters, okay.
Yeah, and so Did you see the map? We're not exactly following a subbottom, so let me make sure you.
Between the two lines, right?
Yes. And then, yeah. So that was.
You can put it down.
Yeah, so just a little touch of
Right.
the western.
So we think we're there.
Yeah.
What we want to do is move 100 meters up there.
And then work our way down with probing.
We need to find out what's up there because it's so hot here.
Not directly.
We need
So
to.
you want to find out where it's cool down.
Yes.
Yeah.
A slight to east.
Yeah.
Yes. So if you.
Between the two lines. Zoom out. Just super.
Let's go parallel that one.
Yeah.
No, dijo que con Ticon.
So that makes sense. Again, 100 meters.
Una disculpa por la interrupción, pero había que tomar decisiones al momento. Una observación que hemos realizado durante esta expedición es que a pesar de que estemos lejos de las chimeneas hidrotermales, ha habido lugares en donde hay mayor concentración de fauna marina y resulta que son lugares que están calientes, entonces ahí hay alguna correlación y esa es la idea de estudiar haciendo el transecto sistemático. Si tienen alguna pregunta, no dejen de hacérmela. Parece por ahí que en el chat todavía no están muy seguros algunos dónde estamos. Lo voy a repetir, estamos en la cuenca Pescadero, Sur, de hecho en el Golfo de California, es en la parte sur del Golfo de California, a 3.700 metros de profundidad. No, ya viste lo que te contestó el Rafa. Ya viste lo que te contestó el Rafa. Si la temperatura de la zona máxima es 35, entonces como vamos a medir 123. Nos la llevó, ¿no? No sé.
Eso es en ese país.
Porque en los primeros transectos había mediciones de 70, 90.
Sí, por eso yo pensé que son 60. Yo creo que había leído 60 también. Me gustaría estar más seguro.
Sí, yo creo.
You are a geophysicist. Oh, okay. Oh, I see. That part. You know, I like my rocks pretty, which is why I'm not a basalt guy. Interpretation is wrong. Actually, okay. You know, I always had this impression. To know what it is, you need to have a whole section of microscope.
A mí no me llegan
That's good stuff.
algo
Lieutenant, were you calling us?
haciendo refresh.
That's why we can hardly hear you there.
Okay, let's pull it out, please.
Yeah, I just got the waypoint ready, we're not ready.
Coming up.
Still useful.
Now, what is it?
Thank you.
No worries, moving out.
What's sort of long?
It's class, so I can't go as far as class, which is good. So you can't go express class.
¿De cuánto crees que sea?
How coarse is it? Is it close to the bed?
It's 4 meter scale beams of glass in there, there's good rock fragments from. So it's
within
gonna be close to the clearance one from sidewalks.
And
It'll speed.
can you tell that it's a submarine eruption?
Has to be erupted.
Okay. Is it 1,000 meters deep, 1,900 meters? Okay. So there might be some volcanics somewhere along there.
If I'm right. Like I said, it's just the interpretation of the shares these things. So.
Let's get, so are we getting that?
It's gonna go back, because it's a day. We'll cut those sections.
Yeah, okay, so basically.
It's going home. Dave said, he said, you know, we're not, lots of miles from the wells.
Alright, so then we'll just,
Yeah, so, it's gonna go home regardless. The rest of the rocks.
yeah, I know I've been through this conversation, I
Between rock and dig, what you have before you got this.
just the direct under what you to. I just know I'm expecting to pay for analysis.
It runs plants, because
So as you can see, as we transit here for the next station, which is gonna be only 100 meters north, we still find a lot of evidence of ecology around here. So our guess is gonna be still hot. The next station. Saludos, manchitas.
Could we do this thing? This is kind of the right terrain with backgrounds.
Sure. Once we are positioned in the ground and done with the
This is, looks good.
Sure. Sí.
Do you want to do it with the sword, or do you want to just do it with the, you want to just do it with the arm, or with the sword? Yeah, but. No, I don't like it. No, it's, so I can either get it.
So see, while we're here, so we might we talked yesterday about getting a Cusco for run near the vent.
Yeah, right. Yeah. It's
On the right, like the once we're approaching the
If we go
vent.
back south again,
Yes.
then I'll be on the lookout for a place to stand for, I guess.
Okay. Good.
6.84.
Wow. 6.84 for the Seafloor, yeah. And we were assuming it was going to be background.
How far north of the edge of the mountain?
We were just like, well, it's actually shown there, over there, but it was just like in the intersection of these two lines here. So that was where we were
Okay.
heading. So
Okay, so that's roughly 100 meters from the mountain. Of course, there's that inactive mountain there too, but yeah, that's pretty high.
On the seafloor?
van a tomar la raya. Es que Alex pidió hacer una raya en el sediment en el poke. Sí, una raya. Va a llevar 2 minutos para su proyecto de Armos.
Sí, vamos a hacer.
Okay, I think the probe is on. Okay.
So. Okay, so what you just saw is actually J-Road, one of our pilots, drawing a line in the sand. Well, not the sand, the sediment, rather. And that's because, I don't know if you knew, but we have an artist on board, and she was entailed with the homework, the project of doing an artistic work out of this expedition. So she requested this morning to do that in a place where we could find some evidence of life. And so that's what we were trying to accomplish a few minutes ago. So no, Rachel, we were not trying to write our name, though. It would be a good idea. Good point.
Also, if you see the temperature, it's right? Yeah. Okay, we are ready to insert the probe, please.
Okay, probe coming down. Just a sec. Okay, coming down, ready?
Yes. Thank you. So the probe went in. That was a nice speed, J-Road. Thank you. Ah, look. Really nice spike. Oops. Oops, sorry, no, wrong direction, wrong direction. Okay, Diego, next one will be another 100 meters, please. Same line.
So still warm here, a little bit colder.
It's a little bit colder.
Yeah, 1 degree colder.
It will be about 2.5.
Okay.
So yeah. So that's 4 degrees in 100 meters. So it's kind of considerable cooling. But on our way back down south, if we consider that we need to take an intermediate measurement, we can do it just to see.
So you suspect we go north to get to colder, and as we cross the south, the hotter.
Yes.
What do you think it is right here in the vents? Somewhere in here.
Yeah, definitely. Before that, if we are already, it's what we were last station. It was 6 point something, and it should go up pretty fast as we approach the vents.
What do you think temperature is here?
Well, I don't know, but it could be it could be the vicinity of 30 degrees, something. Yeah. But but last.
Because we took probe here, didn't we?
That was, I think, I was a waypoint. I don't remember.
That was a couple days ago.
Yeah, no, that particular profile wasn't too hot. I think it got only, yeah. So, but in the last expedition in 2018, I think in the central mount, where the orange dot is, we measure 123.
There?
Yeah,
Wow.
around there. So it was very, very hot. And in the other field, we got aggregate chart values as well, like 90, 70, 60.
Wow.
So for us, like finding 30 was already kind of not that shocking.
So when you say 90 degrees, is that at a meter or 60 centimeters depth or on the surface?
No, it's a gradient, right?
But like, what's the differentiate like from the top to the bottom? 5 degrees and 6 degrees.
Well, if no, that's the temperature of the water, you know that.
The surface is
water.
always 82 degrees.
So it will always be very much more colder. But no, it's about the since the probe is so short, it's pretty much the temperature of the sediments in that. Yeah. Exactly.
Where is it?
Are
Mm-hmm.
you gonna be going further north after the next one, or is that the last one?
I think this probably will be the last one that we will go north.
Okay, get the probe out, please.
Okay, probe one out.
Thank you.
Roger that. Moving on.
So I noticed when we pulled it out, it's just the friction that makes the because it jumped even higher, but the water temperature is 2 degrees.
Yeah, actually, it's just the friction from the inserting the probe that provokes that first spike breathing, and then the real important one is the second one because but you get the whole measurement complete. Hmm.
So these are more just kind of like exploratory probes. You're not shooting the pulse on these ones.
No, because we're not. Well, the last one, because we're kind of thinking that we will be cooling down and approach the background value. So once we're there, we always want to finalize the transect, which will be the northern boundary with a complete measurement.
Right.
So if the measurement just before that one is not completed, then you just use the assumed thermal conductivity, it's okay.
Yeah.
So that's why sometimes you do the full measurement, sometimes you don't.
You get more samples in the day.
Yeah, exactly. But you just save time, so it basically translates to getting more
More data.
samples. Yeah, more data.
How far you are from the point?
20 meters.
Otra vez había un montón de bichos, ¿eh?
Maybe let's do one with a little bit, few meters more, and then let's do a measurement because there are a lot of clams. Let's see if it's higher than the last one.
So before the 100 meters mark?
Yeah, I think so.
So, sorry, move another 100 meters?
No.
A few more meters and then
Oh, a few more. Okay.
a few more.
We don't have to reach all the way to the 100-meter marker. We just can stop here because, yeah. 2.76.
Wanna see that?
No, espérate. ¿Ya empezaste?
Okay.
Yeah, it would help.
How far away were we from the previous point?
100 meters.
Oh, no, we're
No, it
less
would-
than that.
A little bit.
So I think that'd be 92 meters.
Okay. Karina y Florian para que lo registren 92 metros.
Okay.
Es
Please insert the probe.
Ready? Okay, coming down.
92 metros. Could you answer the box question about the things of the image that's shown in the
Yeah, I was
file?
just looking around trying to decide whether he's talking about the blader mouse view or. You know, so
I'll ask
is
him
he's seeing which view?
which view.
Skip view of the probe right now.
There you have an anemone on front of the right, on top of a clam. What do you think? Cool, huh? I think he means the 3D one, right?
I think so, but
Yeah.
I'm answering.
Okay. I'm gonna get a full measurement here. It's pretty similar to the previous one, that the rock says.
Yeah, it's all one.
Entonces hicimos del punto de partida 100 metros, luego otros 100, bueno, fueron 92.
Hicimos unos 100 y ahorita estamos en 92.
Nada más hagamos dos hacia el norte abajo. ¿Llevamos tres? ¿No?
No, dos. En total llevamos 13. Ese transect.
Fueron dos de 100.
Con el primero aquí, 100.
Ah, sí,
92.
sí, sí. Ya, perdón. in my sense, something here is happening between. So Rob said that this last one would be a little bit higher than the previous one. But we also realized and observed that there were more animals around this spot. So that's why we. And so we are looking at this, intercalation of sites where it's cold, a little bit colder with less animals on the surface, and then hotter again, and then I don't know. It's hard to know what the mark the end of this dance.
It's what the rent is. I think it's a rent screen. Eso lo vi en el 2018, lo vi, se los dije y no me pelaron. Los biólogos. Y, como que no, y ahora sí. Son 100 metros más.
Es lo que estábamos viendo, que cuando, es lo que decía Rob, que pues que en algún punto tenemos que turn around. Apenas nos va a dar tiempo de terminar ese trabajo hacia el sur.
What's the number of the current measurement?
8.
What? 8?
Yeah, measurement 8.
Measurement
No,
number
no.
8, I was asking. Yeah, so, okay. Okay, so if I understand correctly, it's 100 meters further north, and then we will be heading back south.
Yes.
Okay. So the next measurement is going to be 100 meters north, and then we're going to want to start moving south. So whatever you want the ship to be doing, do a naval now.
Just straight back between these two lines, right?
Yeah, we'll be heading back down the same direction, and we may fill in, or we may, I don't know what they're going to decide, but we might fill in a couple of points, probably closer into Vance, and then try and get a bit to the south before we're done today.
Good.
Okay, let's pull it out, please.
Okay, come on up.
Roger that, moving on.
Thank you.
Okay, people, moving on towards our next station, another 100 meters or so, which will mark the end of the transect in this side, and then we will turn back downside towards the bent fields. But still there's a lot of evidence of animals around here, so our guess is that that correlation that I've been talking about is true, then the heat flow values that we're going to find in this place are going to still be a little bit high. Yes.
hit the button.
No, thank you. No. ¿Quieren conmigo? Isa. Ah, no sé. Es lento.
Okay, you're ready. Get the program, please.
Okay, you ready? Coming now.
Thank you. Thank you.
Huh. If I've been winning.
Well, that's actually, JaichMaa. Right, you know, these were from mammals. We gave them some of our beacons to go find what's going on. That's what we want. We have some other guys. Go right.
stream. It's just three. It may back out a week out.
6, 7, something.
No, 3.
Hmm?
Go on 3, yeah. So let's do like the 7. That's good. So so let's go to Seafloor, and then decrease a little bit, and then so you go back, and then all the cells, and then
Yeah, that's gonna be fun. I don't mind it. I wanna watch Seafloor. I don't mind it. I just wish I had birds.
Actually, does, but I was thinking that was again 1 year, and that's
So this time we have
What's that little anomaly in the middle?
one impact.
That's probably noise, but did you see that the yellow one stayed flat? That meaning it didn't want to.
That's not what you write.
Well, we can always manage with the rest of the thermistor. It's always ideal to have them all working, but it's okay. You know, the last two measurements were pretty consistent, so we're expecting this one to be consistent as well, which is very interesting. How they're not decaying as we, you know, in this direction they decaying very, very fast, and in this direction apparently stay hot longer. So
So does that mean like that maybe this is more like a fault right here?
yeah, like there's whatever is driving the heat around here is apparently the signal is stronger in this direction.
Well, it makes sense because these are all in line, right? North to south.
Right,
Even this one up here, he's a little bit out. So that
right. It's a good observation. You should be a scientist.
I'm just looking for you. I'm standing right here. I didn't see you.
we should do is go check out these. Oh yeah.
Sorry?
We should check these little guys out.
Yeah. They might be just a little, you know, little. The question is,
If they are, they're anomaly, but then there's other two up here, like this one here.
yeah.
Hello, Frank.
So you're leaving? Don't leave me.
Yeah, I gotta
Done
go.
it very quick.
Sorry.
That's
I'll be
fine.
back.
Okay.
Basically, we're probably there. And we're gonna turn south and then, yeah, we'll show you that makes sense. So there's this line here, this line here. So they wanna, just kind of back to the outer limit, and then turn around and go back down this line towards these vents. And probably just sample this all from here. Okay.
How far south are we going?
We're actually gonna go 50 meters south from the first point,
So all the way back to the first point,
So
then
very
50
far away.
meters south
the first point on this
on this transect.
north-south line.
Yeah, yes.
So from this one right here.
Okay, get the probe out, please.
Yep,
And let's head back. Thank you.
Yeah.
I think that's correct. You
Yeah,
agree,
that's
Raquel?
correct. Yes.
Okay. So yes,
Yes.
50 meters south of that point. Along the projected line.
Okay, thank you. So we're ready to move whenever you guys are ready, right? Okay, people, moving on back south.
Before we move, see if we can zoom. Is it all right if we zoom the camera a little
Oops, sorry. Ooh, no, that the other direction. Sorry, son. Oh,
Yeah.
uh-huh.
See if you can zoom it back.
I think that's the full zoom.
Yeah.
Uh-huh.
Oh, you are full zoom.
Yeah, I am. Yeah, we were already at full zoom.
Okay. I don't know what that is.
All right. Thank you guys. We're ready.
Yes, we're going to be going the opposite direction now. So put in a move, it's about 300 meters to the south.
Do you mind? That's awesome. Thanks, John. That's perfect, man. That's why I like that. He's helpful. He's helpful.
Sorry, I have an app on start this map before I get it.
But John thinks it's stupid. It's nice.
You need Google Maps.
Sure.
So the green dot is the first measurement you did?
Oh no, we're a long way still.
Ah, okay.
No. We got
Ah, okay.
we got
We got found our tracks.
Okay.
Sebastian here.
So in practical terms, when we're making these moves at this depth, and it doesn't seem like conditions are particularly challenging, but so you're moving the ship and you're moving the ROV and you're pulling the tether through the water.
And if we start outrunning the vessel, then we're trying to pull the 3,000 meters from the boat.
¿Volvió a subir
This
tanto?
big thing.
Okay.
Sí,
Now,
sí, subí.
do you?
Pero sí se vio más conchas
It
también.
seems like you're doing things in concert, so you're not moving the ship ahead of time, and then
We do sometimes, depending on which way, but
And if we know.
we can't have the vessel like come like right up on top of us.
yeah, they get antsy about that on the flyer too. It's the one thing you never do.
We'd have to camp there and, make the turn level on itself.
Yeah, right. Do you have a turn counter displayed? I mean, we haven't been doing maneuvers that up there make a problem.
So see where you see like the heading up there, it says 170?
Yeah.
The bottom right corner of that block.
Oh, there it is. Yeah.
And it's also on this overlay on the top right. Great, Garby.
Elevated bridge.
Hey, is there any way that we need to be doing like before, or are you piping it in?
Yeah, sure. I'll split it up a bit.
Okay, thank you.
Alzheimer? No, Parkinson's, I would say.
vessels for that. Those ones probably watch by.
Sir. I'd like to make one more stab at passing you a useful grid for Tether. Can you send me that, you had an example that was large that worked? Can you send me that file and then I can try and duplicate it, later tonight?
John got it to work 99% of the way. I think there's one outlier in point that didn't show up when I printed it, but it shows up in zero. So it doesn't even show up the first time I tried to import it. It's after I import it. There's some like 5,000 meter above sea level line, and it's off the area. It's just like right at the boundary.
Oh, okay, so it's just a...
Yeah, and it's just making the model just hard. We might be able to search for that in text language that one time. I was trying to find it, but then I don't know. Or trim it down. Well, I can't, I can turn off the section that has it. It's only right at the edge on the right.
So you've been messing with the file I sent over.
Yeah,
The problem is the numbers that are in it not important.
No, they look the same. It's something. It's. Yeah, it came out very similar. Yeah, unless he was able to pull it in. Okay. And it was fine. And then when he exported it out, I opened it up and it appeared that it was. I don't know. I don't know what it was. Okay.
All right. Thanks for
Yeah, we're pretty close to it. And you want it exaggerated with it, right? To make it look good.
I do want it to look good. So your judgment on what that means is fine.
Yeah, I guess so. Cool. start losing. Guys don't count weird. That's not even pretty good. Andre the Giant walking through the wall there. Try to pull up. You ain't gonna get that.
Unmute.
They said it's on the north.
Got a card box.
Maybe there's still a guy.
ROV bridge. Are we, am I stopping the waypoint?
Yes, please.
Roger.
It's quite a mess in the line to should just be there. That's about where it's at. Wait, hold on, that isn't over here. Not too close. Careful. Grab the states here.
Can't go no faster. Can't pull the boat.
You there yet? Are we there yet? Did you see that question on YouTube about where Lake 3 is going to be at?
Yeah,
Oh,
yeah, no worries. They were requesting to look at the zoom at the creatures.
that had 55 meters to go. I think that's like 20. It's going 0.2, 1.5.
Okay, people, we are approaching the site of our next station, but while we are there, just wanted to let you know that yes, the second leg was all about heat flow and water sampling. So the third leg will be starting on October 28th, back to Pescadero as well. So I think you're gonna have plenty of time to look at the ecology that lives around these vent fields in detail, because of course as biologists they are spend a lot of time of their bottom time looking thoroughly at the vent fields and the microbial mats as well. So it's gonna be the same scenario, the same regions. They might choose to start in Auca, which is another vent field located not far from this one. But as far as I know, they are going to be working close to these vents as well and expanding what they already did back in 2018. So if you are biologist and microbiologist lovers, so you just have to wait for a few more days and then you will be in action with the biology leg. I hope you're finding this heat flow leg though not too disappointing.
Can you drop a mark down here? That was a really good size plant. Just drop a mark point. Can we drop a mark point?
We're landing right here.
Or landing, okay. Because that was a really good size plant kind of do for the experiment we might want to run next cycle. So maybe just make that a note. Possible planning community for detailed heat loss experiment. And then put Victoria's name somewhere so she can search it. Just Clam. And they are solar pipes.
Oh wow. Look at all those clams. Beautiful sight. It's gonna be pretty hot.
So is this going to be measurement 10?
Yes.
Yes. Yep, poke all the way in.
So is
No
this point
disturb.
enough to note this point, or do you want it noted that it's dense to the north?
Yeah, this is good. Yeah, no worries to north. So I guess this is getting too many plants. I like that one because it had a nice defined edge. And we could go across it, be in and out of plants.
Are you still moving?
No. Oh, yeah. Sorry, I was moving the camera.
We gotta wait for the, yeah, the umbilical to catch up. I just got that, the sword in it to try to.
We're down.
Okay, we're down.
Yeah.
Okay, this is just like 10, there are dense plants, here's sea beds, there's down, no plants, no plants.
Okay, let's get the program, please.
That boundary is about that far down.
I would say 5 meters.
Let me know what's going on. I can't see it.
Yeah, wait until you feel comfortable, no worries.
Looks good. Thanks.
What?
Now we're cooking with
That's a big spike.
Pretty warm yet?
Look at the graph.
What's the top temperature right now?
It's 4 something and but going up and yeah,
What's the
already.
hottest y'all found so far?
Well, in the whole during the whole transect it's 34.9,
Nice. That,
But-
of course, really close to the.
really close to the vent. But last I was just telling what's the name of the guy before you? Adam. Yeah, so sorry. I was just telling him Adam that at that point where near that point, like 20 meters away from that 34.9. On 2018, we registered at 123 point. So it's very hot. We know it could be very hot.
Rob sees it. I shared my screen with Rob.
How far are we gonna move next?
So Rob sees this.
I think we're gonna go short.
You know, the thing is, I've used these as my
25?
notes. So, between this and the automated logs, so.
Probably. I'll just confirm you in a minute. Give me just a few seconds to see.
Yeah, sure. That's good.
¿Esta va a estar completa? Sí, ¿no?
Yeah, 4 clicks.
RV bridge.
Yes, I have another update.
Yeah, sure. Moving on.
It's gonna be 50 today.
Okay, get the probe out, please.
Oh, coming out.
¿Registrado que sí?
Sí, no, mira cómo está. Se fue el amigo.
Probe's out. Moving to the next one.
No pican entonces. Yes, please, thank you.
Is that a plastic bag?
Yeah, look like it.
Okay. Okay, let's try to find a flat spot.
What's that?
A flat
You wanna
where
land
it's
here?
flat.
Wherever it's flat and you feel comfortable landing.
Okay. Doesn't look like it's gonna be flat.
Is it tilting? Well, the
ROV bridge. Am I stopping the waypoint to carry on?
We're gonna be stopping at the way. Alright, next I'll move you just a little bit more. Alright, I'll have you go to about there. Yeah.
Roger that, thank you.
Yeah, right here.
it's over. Okay, let's get the program, please.
Rope's coming in. Rope's in.
Thank you.
That's true.
So the last one was pretty high, 11.24.
What's this one getting up to? 8?
Sorry,
What's this one getting up to? 8?
this one is the one that was just made.
Yeah.
It would probably, yeah, a little bit lower, I think.
In these last few stations, has anyone seen bacterial mats or any evidence of diffuse venting? I don't think so.
No, I don't think so. No.
How far are we moving next?
Probably another 50 meters.
What was the one before? 11. Highest. 11.4. Highest. All over the place, this one, I think it's a bit
Just
low.
No, es como un tipo cangrejo, creo. Esta la vamos a hacer completa, ¿no?
Sí, sí, hay que hacerle una porque no vamos a hacer.
So here we're gonna perform a complete measurement, and so you can see now at the graph how the heat pulse has been fired and all the thermistors are going up in their signal. And so we'll see how hot continues to be here. The previous spot was pretty hot. There you go, fella. Yes, it's a squat lobster in Florida. Nice view. You're so good at these things. I'm so clumsy. They're super.
Touchy.
They're super touchy. Wow. Cool.
Okay, let's pull. Oh, give me a second.
Say, pull the probe.
No.
No,
No,
sorry.
no, sorry.
What long it is.
Sorry about that false alarm.
Sorry.
He's counting minutes wrong. So somebody in the chat is asking what's the scariest thing that you guys ever seen under the water?
That's very great thing, but I'm not in it. The remote control toy. I want to see the scariest thing down there.
So you haven't. I think the question is have seen a creature that is kind of not good looking, because so far I've seen it. They're all beautiful, very different.
There's definitely some fish that only a mother would love.
There's some freaky looking fish.
A
Yeah.
walk-on shark, that thing.
Okay.
But that thing's cool. Not scary. All the sea snakes in Australia, all the sea snakes in Australia, that was a little off-putting. Like, they really have a little swimming position. There's a lot of sea snakes. And
I
they're
bet.
curious, too. Scary. Hallucinate is scary.
Okay, think we are ready?
For real this time?
Yeah.
Okay.
Sorry.
It's alright. I'm just messing with you. Coming up.
It's late.
Robe is up.
Thank you.
You can move back
Okay.
to the next stage.
I once had a lizardfish stare into my soul. I didn't try that. Cody says he saw a megalith now. Nobody. This might be bacterial bat.
Pretty dense.
Or it's just a whole bunch of anomalies.
That looks like it's just a bag.
Yeah.
Yeah. Okay. So
Maybe stop here. And
Yeah.
then do one here before we get into the field.
This one right here?
Yeah.
Yes.
Okay.
yeah.
On the
So
boundary.
Oh look, it's actually.
Let's poke before we get the probe in. Yeah.
the next measurement's 11 or 12.
It's 12.
I think definitely soft.
Okay.
Okay.
Let's wait a few seconds to.
Did you finish that bag of gummy bears?
All by myself, yeah.
Oh my goodness.
Nobody else in here helped.
And,
We just opened it this morning.
Thank you, Joe.
Helped me for like.
Ya. Ah, pero pues, pues empiézale. Wow. Wow. You see, they 10.62, but like we're really high thermal conductivity. Like
Okay.
1.17, while we were always assuming 0.8, 0.7-ish. So that's interesting.
Yeah, and as you all have described it, the estimates of the thermal conductivity have been
Okay.
robust.
Let's get the probe in, please.
I'm going in.
Is, in this context, is thermal conductivity
Probe's in.
more
Thank you.
controlled by density or by composition?
Well, I think by a little bit of both, but I would go more for composition. However, I mean, how heterogeneous this terrain could be, right?
Yeah, I mean,
So
it's
that's-
just, it's everywhere that we're able to make a probe that's soft,
Mm-hmm.
right? So the density probably doesn't vary that much.
Right.
So,
It's
so
probably
the idea that
specific.
thermal conductivity is varying by more than 25% or so.
Mhm.
It's- I'm wondering what controls or what the explanation for that is.
Right, because we were also tested, well, sampled or measured in other soft spots as well, and
And I
you
think
see
you're measuring bulk conductivity and not rain, so we're also doing the water content in the sediments. That's very important.
Okay. There.
It's very hot. It's nice.
yeah. Well, over hearing us says composition is more important, but porosity also plays a big role.
Can we put the waypoint?
Yep.
Here, please.
No, put a waypoint there. Put a marker there.
Oh, Marcus, sorry, Marcus.
Are we already? We have one for the. Yeah, there's one for the probe right there.
Oh, okay, that's fine.
Is that fine? Okay.
Yeah.
We can label it something else.
No, that's fine.
No, that's fine. How far away were we from the last
That
station?
was the just over 50.
just over 50.
Yeah, it's like
So
right before the map was 50, like back here, and then we came right up to the map.
okay.
But we're approaching the east-west line, right? So
Correct.
we've got measurements that are south of us along that east-west line.
Go to go up the top, C70. Okay, go hit up. No, hit up. So it's up. Hit up. Now hit select. Go. There you go.
Seed filter.
Yeah. Can you zoom out on that for a second? Yeah, so we're approaching that. You said east-west line.
How big do you think that this mat could be?
How big the mound? Or?
No, the mat. The mat that will this concentration of clams. I know it's the proper mat, material mat, but
Yeah. I'm hesitating because the accurate answer is I'm not sure.
right.
It seems to me that it was not stretching to the horizon, which is the field of view that's lit up by the ROV. So it's probably less than 25 meters across or so. But I'm probably very wrong about it.
Right. Yeah, just
It seemed to me, my recollection was that this was a patch. It wasn't to apparent infinity.
right. Because we would like to make another measurement on the edge of the mat, whatever it ends.
The other edge.
The other edge.
Yeah, I think we can find the other edge for sure.
Yeah.
And just to confirm, hold time is 4 p.m.
Yeah.
If we're in the midst of a cycle, we can finish it.
Okay. Good. Thank you. We're close to pulling up, right?
Okay, let's get the probe out, please.
One probe. Probe's out. Thank you.
Thank you. So can we kind of fly over the
Yep.
map to
And then
see?
we're gonna try to land on the other side, is that right?
Yes, exactly. The other edge.
Pull out. And here I'm just kind of using it as a about hold some ground. I just want another edge of this map. This back here. Thing like right in here.
What do you think, Florian? Or to close?
A little bit further,
A little bit further, okay?
Yeah.
and then a few more. Yeah, maybe here.
Here?
Looks
Okay.
good, yeah.
Coming down.
Thank you.
Thank you. Yeah, let's poke before we.
Yep.
So, yeah, okay, thanks.
Yeah, if I poke here for Florian.
Yeah, sure.
Sure. Go ahead.
Yeah, looks good.
Yeah, looks good. So how far away are we from the last point?
We can measure it right now. I'm gonna add a marker here in a minute.
Yes, please.
Just go from the look.
Ahorita te la doy el espacio. Precisamente.
This is still over 8 meters.
Over 8 meters.
Still over 8 meters.
Okay. So, espaciamiento de 8 metros entre el anterior y este.
Okay, let's get the probe, please.
Probe going in. Probe is in.
Thank you. Wow.
Oh, wow.
Wow.
Would you say 30? 30 was max? 30. No, no conductivity measurement here.
No, no, it's too hot.
How far was this move?
9 meters.
Only 9 meters. to
Yeah,
the other
eight.
side. Okay.
8.7, something like that.
So that's what I did, right? That's what we did.
Cuando puedas, para ir a lo de la llamada, vamos a empezar en el puente, entonces para darte todo su...
Okay.
We still can't. We need to make sure we're not coverage. We still can't.
So this one takes, let's say, it's
So we'll times it 4. But if we're in a cycle, so go ahead and do the move you want, and get it going. 4, 4, 4.
okay. Okay, sure. Okay, thanks.
Yep.
So the question is just how far away?
Yeah, let's see where we have less sea life, and then we try to get one less measurement. If you
You have a measurement along the line south of us, so I would want to go further than that, because we've already done profile.
Oh, okay, sure.
Right? So I would go at least 50%.
15 meters.
At least.
Okay.
Make sure that we pass the line of measurements we did yesterday. Do the mark points, okay. So why don't we see over there the line of measurements we took before.
Mm-hmm.
I would suggest going at least 50 meters to the south of that line. Right, so we're 20 meters north. So an aggregate 70-meter jump.
Yeah, well, Rob has a point. He says
Okay.
that he can do a detailed survey. Well, he's in favor of doing a detailed survey on one of these spots where we see a high concentration of life and then correlate to a line of spatial density of light. Having more points will help quantify that correlation. I think for that we may want to do 10-meter spacing, depends on the size of the field. So yeah, I see your point of you're getting, but this is really flat. So I agree with him that it might be better to.
Okay, but you're getting one more measurement today.
Yeah, I know that.
Okay.
Okay,
Are you doing the full thing here? Or?
No.
Right,
It's
it's
too
too
hot.
hot. Okay, so you're going to be done in a couple minutes.
Oh.
5 more seconds.
Yeah.
Okay, get the probe out, please.
One probe.
Thank you.
So we decided to just for the local mini survey or.
Oh no, let's go
high
50
resolution.
meters.
What?
Let's go 50 meters.
No, Rob said that we go 10.
But maybe not today, maybe not. I mean,
Yeah. So are we on the same page? No.
Well, either way, we're going to come back in 2 days. So this is one more measurement today.
So 4 and make up your mind.
yeah, 25 meters. Go 25 meters.
25 minutes.
Okay, 25 meters is going to duplicate a measurement we already had.
Ah, okay. So go
Right.
50
That
meters
was-
then. Okay, sorry.
50 meters.
Scroll out.
Okay. Okay. I think that. Yeah. Okay. Good. So we good. I was worried about frying ends, bro.
Are you waiting on us?
No, we're just getting our measurement.
Oh, yeah.
Right. There's a pan and
No, sacamos la son. Is it up?
No, they're trying to get the way. So are you?
Okay. But the probe is of the sediment, right?
yeah, the probe's
Yes.
out.
Yeah, the probe is
Yeah.
of.
They're not letting you define the point.
Just leave it there, I'll just fly to it. That's 53, so we're still at the top of that. Okay. Patches of rats, huh? Bless you. Wow. Yeah. We did. Yeah.
So Dave, I can have another call with Alex. So my
Yeah, so I'll finish up. Yeah, excellent, great.
So, tengo otro
Give me a line.
dices a los que estamos años, pero que gracias y que short call, guys.
Okay.
Thank you very much.
Of course.
Thank you for for me.
Alright, sounds perfect. Thank you.
Oh, thank you.
See, we do need to add a marker there.
Well, hello again. This is David Kress taking over for Raquel. She has to take part in a ship-to-shore outreach event, and so I'm going to finish this very end of this dive off. We have just arrived at about our the site for our last heat flow measurement. You can see we've stirred up quite a bit of mud. Among the things that we have been discussing a lot, both via chat with people on shore and verbally here in the control room, is the apparent correlation between patches of dense chemosynthetic communities and the heat flow. Even in areas where there's no clear evidence for direct diffuse venting out of the seafloor. Another piece of this, which I just noted as we crossed that last patch of dense clams, is that looking at the AUV meter scale bathymetry, that patch does seem to be concentrated into a shallow depression, and by shallow I mean it's deeper by perhaps 30 centimeters or so than the surrounding seafloor that has less dense clams and very possibly lower heat flow. So it's a very subtle feature, a feature that you can't see with the ROV video, but which is evident in the meter scale bathymetry that had been collected by the AUV 3 years ago. So we are waiting for the water to clear. So nominally our pull time is in about 30 seconds or so, but we do have the clearance to complete this measurement that we're just starting now. So we'll go ahead and do that, and then we will be coming off bottom for the end of today's dive.
Okay, get the probe in, please.
Probe going in.
So in the chat, Lisa has asked, does it seem that there's more biology when the temperature readings are higher? We've been asking us, I think the same question, but posing it just slightly differently. We've been asking amongst ourselves is, we're seeing an apparent correlation between the density of the benthic communities and the heat flow. And heat flow is not exactly the same thing as temperature. The temperature on the seafloor is controlled by the ambient water, so it's actually really close to ambient 2 degrees C, except where hydrothermal fluids are directly coming out. So we're really looking at the heat flow and more or less equivalently the temperature gradient in the near subsurface.
Energy.
And as Florian keeps correcting me, you should think of this in terms of energy, that it is the energy, and in fact, many senses, the energy that is driving, in conjunction with chemical energy, that's driving this system. And yeah, that is the question that we're asking based on what we have seen and measured here over the last 3 days. And that's a train of thought that is different than what we arrived with. And so you're seeing the same things and hearing the same things we are, and thinking about it similarly. Okay, so the probe has been inserted for this last measurement. And you can see where we are is much less densely populated. And the deep thermistor is rising to about 7 degrees Celsius, which is rather less than it was at the previous site, just a few tens of meters back to the north. So I see in the chat, was the clam question answered? What was the clam question, please? Right. Okay, and I see James Driscoll asked, has the mat evolved to maximize its energy source? The mat, I presume you're speaking about the microbial mats, which we're not looking at right now, but which are extant basically everywhere that there's direct flow of hydrothermal fluids out of the ground. And those bacterial mats, of course, are composed of bacteria and also probably archaea, and they're probably in many cases multiple organisms. The biologists, I'm sure, and microbiologists can correct me as necessary. But the way that I would put it is that the mat has evolved to adapt to a particular environment, a particular context here. And so where you see a particular form of bacterial mat growing is where it has found the conditions that it is particularly well adapted for. And yes, it is about its ability to extract energy from its environment, and also about its ability to survive in that particular environment. Do we know what species the clams are? Well, I heard Z come in earlier and tell us, I thought.
These are not the syllabi. I'll look that up. We have
Okay. Z had found it. He is looking it up right now. So this looks to be a good measurement. There's not much noise in the thermistor readings. And it's low enough that we'll probably get a good thermal conductivity out of it as well. So it's a good last measurement. And we have looking forward to the 2 dives we have remaining here in the South Pescadero Basin. It is our intent tomorrow to go to the other vent field, to the Auca vent field that's a kilometer or so to the north. We collected heat flow there 3 years ago and published a paper on that, first authored by Raquel And we will be doing some additional heat flow, augmenting that survey, in part with lessons that we've learned, both in 2018 and earlier this week. We will also be attempting to sample hydrothermal fluids from 2 of the vents. So tomorrow, the early part of the dive will have a lot of video of maneuvering around the hydrothermal vents themselves. And then we will go back into the heat flow. And then on Sunday, we'll be diving again here in the South Pescadero Basin. We will be doing heat flow and more heat flow. And exactly what we'll do is going to be a big topic for conversation. We have another perhaps 15 measurements that we can do, and we are going to be looking at a variety of options as to what questions we want to try and answer. What's our highest priority? And it's going to be a conversation that involves the folks on shore and the folks on the ship. Now Z is standing right here, and he has the answer on the clam.
The most abundant one we're seeing here is a vesicomyid clam. And yesterday I did see there were some solomyids, which are less common here. We see them, they're about the same size. And I know, pretty sure that there's another clam which is very small and is buried in the sediment that we don't see, but that does exist here. But Shauna Goffretti or Greg Rouse, who have studied these, will be able to answer those kind of questions a lot more on Lake 3.
Okay, well, we've done the heat pulse for the thermal conductivity, and it's decaying away. So we've probably got another 2 or 3 minutes here on the bottom. And we are looking at, is that a squat lobster or is that something else?
Yeah,
Okay. Woohoo, I got it right. Don't get used to it. See, we're at 3,700 meters. We've more or less been that all day, plus or minus about 10 meters. So Z, you had said something about the black sheath on the clamshells having meaningful.
It does, but not on these. That was how I identified the solomyid clams.
Okay.
These are the vesicomyid. Oh, that might be a solomyid right there. Not so clear. No, I think that's the vesicomyid. So I did see one yesterday where when the clams are dead, this black shell sheath sort of stays behind, and it allows me to identify those. So I could be misidentifying everything here. But one thing you will notice is these clams, once they die, their shells are dissolving. This water is undersaturated in calcium carbonate, and I wish we actually knew how long it takes the clam shells to dissolve here. Maybe someday we'll try and do an experiment like they did at East Pacific Rise, where we'll put down clam shells, and then if we can come back and visit them years after years, we will weigh them carefully before we put them down, bring them back up and look at the dissolution rate. And that would sort of give us a clock to be able to tell how old clams like this are. My guess, based on what's been done at other sites, is these clam shells are probably on the order of a year to 10 or 15 years old, but probably not more than 50 when they died. But, that's an estimate, so I'm not sure if it's true here.
Thank you, Z. Well, that clam has gone on a walkabout. That's quite a distinct trail. It's a clam with a passenger. Or is it a clam? Or is that a holothurian? Or what?
That's
What?
the pink is the siphon of the clam.
It's a siphon of a
And
clam.
then the
So
anemone is hooked onto the shell and going for a ride on top of the clam. As it skirts by, it kicks up down, so the anemone is still feeding on it.
now, so that clam is not in the subsurface. It's not oriented vertical. It's more canted, probably, in
Yeah.
order to.
Because I think it's easier to push your foot out behind you when you have 1 foot to go forward.
Yeah. Okay. So
So being
the
vertical, it's hard to walk vertically on 1 foot unless you can hop.
Okay.
Clams don't hop. I don't think.
all right. So clams don't push or pull themselves around. They push themselves around.
That's what it feels like to me.
All right. Hadn't really thought about mechanisms of clam locomotion before. Yeah, that's a nice siphon picture. How are we doing for it?
A few more seconds.
Okay.
Okay.
Full probe?
Okay, so the probe is coming out. This is going to be off bottom time for us. We really appreciate the pilots giving us that extra 15 minutes to get this last measurement. Now it is really time for us to get off bottom and start ascending home.
Yep.
So thank you all.
Okay. Yeah.
Thanks, guys.
Hey, thank you.
You close, you can see, you know.
Yeah.
14.
Okay, so you can see the pilots
The
coming a bit off bottom and stowing the probe and getting set to ascend. As always, the ROV is going to come up somewhere between about 25 and 29 meters per minute. It's going to take a little over 2 hours to make the 3,700 meter trip back to the surface. Another few minutes after that to recover the ROV onto the deck of the Falkor. In that process, I'm sure there's copious video available of deployment and recovery of SuBastian on the SOI website and YouTube channel. But when they do get up to the surface, near the ROV, there are a set of floats that have been attached to the tether to ensure that the tether just above the ROV is held up. They hold it up by being buoyant. And so in the vicinity of the ROV, the tether is always away from the ROV, so we don't wrap it around the ROV or get it caught into thrusters or anything else complicating like that. And so during the deployment of the ROV, right at the surface, as the ROV is just starting to go down, the pilots and the deck crew have to take the time to put those floats on the tether one by one. And when they're coming back out, when we're recovering, they have to reverse that process. So they'll bring the ROV back to the surface as fast as they can, but then that last bit of the recovery is going to take 10 or 15 minutes because they have to pull up the tether, stop, take a float off, and put it away, and then move on to the next float and so forth. And I don't remember exactly how many floats it is, but it's more than 10, I think, and probably less than 20. And those floats, like most flotation that we use in deep submersibles, is made of syntactic foam, which is glass beads, hollow glass beads held in a plastic matrix. And that is capable of maintaining its buoyancy but surviving the great pressure at depth. So,
Bridge, RV.
did we take push cores today?
Yeah, we are on our way up.
No push cores, no sample. So we didn't collect any samples today, just numbers. I'm a geophysicist, so that's my normal mode of operation. Only take numbers. But tomorrow we will be getting samples. So there was a question here, has Sebastian been extra stinky lately when it surfaces? Well, yes. Yes, it has. Particularly when the other day when Z got his water samples, because while the gas tights really are sealed and hold in the smelly gases, the major sampler is not sealed, and those samples, when they got to the lower pressure at the surface, were fizzy, right? All the gases, mainly CO2, but also hydrogen sulfide, which smells terrible, and methane, were in solution in the fluid, and at atmospheric pressure came out, fizzed out. And so just that water sample by itself was really, really smelly. And indeed, in the lab, as that was brought indoors, it was put under a safety hood, a ventilation hood in the lab. As to the rest of the vehicle, I don't think so much on the vents and the way that we've operated so far on this trip, but on the next leg, the biology leg, where they're going to be going in and sampling the animals and taking mini push cores right in the vent areas, it is going to come back smelling really, really bad. And there's a fair chance that at some of these sites they're going to encounter hydrocarbons, because where you have all this heat and you also have organic material in the sediments, it bakes that organic material rapidly into hydrocarbons, into things that essentially are petroleum, and in many cases some of the higher order aromatic hydrocarbons. Methane's a low order. They go to propane and ethane and so forth. And so all of that is not only really smelly, but in many cases can be quite toxic. And so we've had discussions here in preparation for those dives that'll happen next leg, about the safety measures to ensure that people are protected with gloves and so forth, to be sure that nobody is exposed to something nasty within the materials that are going to get sampled. So A question wondering if the bottom of the ocean was stinky naturally. Well, it depends on your perspective, but by and large, if you bring up samples of seafloor mud, it's gonna be smelly in one way or another, more often than not. Honestly, though, I've never encountered things in the ocean that smell worse than most marine mammals.
Especially gums.
Okay, well, we are ascending, and they're completing the process of stowing that high-tech safety probe. So here now at 3,600 meters and on our way up. So again, this has been ROV SuBastian dive 466 here in the South Pescadero Basin of the Gulf of California as part of RV Falkor Expedition FK 210922 interdisciplinary study of hydrothermal events in the South Pescadero Basin. Again, we will be doing 2 more dives here in the South Pescadero Basin as part of this leg of this expedition, focused on the heat flow with a little bit of water sampling and sediment sampling. And then the next leg, starting the middle of next week, there will be 12 consecutive days of ROV diving that's focused on studies of biology, ecology, and microbiology at these same hydrothermal vent fields. So we're going to leave it at that for today. Thank you all for paying attention and watching the show, and we'll see you tomorrow.